Part of Turkey is sinking, and people are living in fear as they literally watch sinkholes open beneath their feet. Then it gets stranger. The surrounding land is doing the opposite. It's rising. Scientists now think the Earth's crust could be dripping, like it's peeling away and sinking into the mantle. And if they're right, this could also explain how the surfaces of other planets change over time. Now, this phenomenon is happening beneath the Konya Basin, a broad, flat region in central Anatolia. While the Konya Basin is slowly sinking, the surrounding plateau has been rising for millions of years. This has been puzzling scientists. I mean, how can a region that's been rising overall also have a center that's going down? That can't be random. Turkey sits on a complicated tectonic zone, where massive plates are constantly pushing, sliding, and shifting around. So, at first, scientists thought these movements alone could explain why the ground was sinking. But a study suggests it's not that simple. It doesn't seem to come from one tectonic event. Instead, the Earth's crust beneath the region may actually be dripping. Now, scientists call this process a manto-lithospheric drip. Basically, in some places, part of the Earth's crust becomes unusually heavy and dense. When that happens, gravity can pull that material downward until it slowly peels away and sinks deeper into the mantle below, kind of like thick syrup dripping. As that heavier material drops deeper, the ground above it can start to sink too. That creates a basin. Then later, that heavy piece of crust can fully break off and sink deeper into the Earth. Once that extra weight is gone, the surface above it can slowly start to rise again. If that's the case, that means this part of Turkey could rise back up in the far future. Scientists then decided to test this theory and discovered something even bigger. That drip can pull on nearby rock, change pressure underground, and possibly trigger even more movement deep inside the planet. It may work like a chain reaction over millions of years. That means our lands can change even without a single major tectonic movement happening at the surface. So, this may be much bigger than just Turkey. It might also explain why other parts of the world look the way they do, like the Sierra Nevada mountains in Spain and the Altiplano Plateau in Peru. It might also change the way scientists think about other planets, like Mars and Venus. Unlike Earth, those planets don't have the same system of moving tectonic plates. But deep inside, their interiors are still active, moving heat around and shifting heavier and lighter material underground. So this discovery may be much bigger than we thought, because it could reveal a hidden force that shapes planets across the universe.
If you had landed on Earth a really long time ago, about 1.5 billion years in the past, you wouldn't have recognized our planet. At that time, all the land was stuck together in one giant supercontinent called Nuna, which was surrounded by an endless ocean. But if you had stuck around, you would have witnessed a planetary-scale disaster, Nuna falling apart. But the most amazing thing is that apparently, when Nuna started breaking apart, it kicked off changes that made Earth a much better place for life. Scientists used to call this part of Earth's history the boring billion. It lasted from about 1.8 billion to 800 million years ago. Not much seemed to happen during that time, hence the name. No big climate changes, no bizarre life forms, and nothing very dramatic. Turns out the name isn't very fair. Things may have looked calm on the surface, but underneath, Earth was changing a lot. Continents were moving, splitting apart, and coming back together. Two massive supercontinents, Nuna and later Rodinia, formed and broke up during this time. When Nuna began to break apart, huge cracks opened between the drifting land pieces. Water filled those spaces, creating shallow seas. Those seas were warmer, calmer, and had more oxygen than the deep oceans that existed before. And that might have changed everything. The new seas created friendlier conditions for life to grow and change. Scientists now think they may have helped early life become more complex. They looked back 1.8 billion years and rebuilt how Earth's tectonic plates moved over time. Plus, they tracked how carbon was stored inside the planet and released into the air. The researchers did this using a new advanced computer model that gave way more detail than they had ever had before. They found out that during the 350 million years of the so-called boring billion, the amount of shallow seas along the edges of continents doubled. Altogether, these coastlines stretched about 81,000 miles. That's more than 3 times around Earth at the equator. At the same time, subduction zones, places where one tectonic plate slides under another, actually got shorter as the continents shifted around. This is important because subduction zones are where a lot of volcanoes come from. When one plate sinks under another, seawater gets dragged deep into the Earth. That water helps rocks melt, creating magma. The magma rises, erupts as volcanoes, and releases gases like carbon dioxide into the atmosphere. So when there were fewer subduction zones, there were fewer volcanoes, and less carbon dioxide was pumped into the air. It went like this. The supercontinent Nuna broke apart, and it created lots of brand new ocean floors in young seas that didn't exist before. These new ocean floors pulled carbon dioxide out of the air. Seawater flowed into cracks in the ocean floor. When that happened, carbon got trapped in rocks, forming limestone. Over time, this process locked carbon away inside Earth instead of letting it stay in the atmosphere. With less carbon dioxide, Earth slowly cooled down. That cooler climate helped the new shallow seas become stable and rich in oxygen. Such calm, oxygen-filled environments are perfect for life to become more complex. Those huge shallow seas near the continents acted like safe nurseries for early life. They may have helped eukaryotes evolve faster. Eukaryotes are living things with complex cells. Cells that have parts inside them, like a nucleus that holds DNA. Every animal, plant, and fungus on Earth comes from these kinds of cells. So when eukaryotes appeared, it was a huge moment in the history of life. Scientists already knew that eukaryotes showed up during the boring billion because of fossils that are about 1 billion years old, but they didn't really know why this happened at that time. Now, scientists want to find better preserved early eukaryote fossils to learn exactly how complex life first evolved. Life on Earth started over 3 billion years ago. It began with tiny, simple microbes and slowly turned into a huge variety of living things. We still don't have a clear answer about how living things came out of that early primordial soup, but even though there's no final answer yet, scientists have come up with several theories to try to explain how life on Earth may have started. Some scientists think lightning helped start life on Earth. The idea is pretty simple. Lightning is a powerful spark, and sparks can cause chemical reactions. In a famous experiment from 1952, scientists showed that electric sparks could turn simple gases like water vapor and methane into amino acids and sugars, which are basic building blocks of life. This suggested that lightning in early Earth storms might have helped create the first life ingredients. But later research showed Earth's early air wasn't exactly like the experiment. Still, some scientists think volcanic clouds could have had the right gases and lots of lightning, making this process possible. Other experts think life may have started on clay. One researcher suggested that tiny clay crystals could grow and stick together in patterns. As they did, they could trap simple molecules and line them up in organized ways. Think of clay as a kind of early organizer. Today, DNA tells molecules how to line up and work together. But what if clay had been doing a similar job before DNA even existed? It could be helping molecules arrange themselves until they eventually learned to organize on their own. This idea was interesting and got a lot of attention, but most scientists don't fully accept it yet. Another popular theory is that life started at deep-sea vents on the ocean floor. These vents are cracks in Earth's crust where super hot water shoots out from deep inside the planet. As the water rises, it picks up important chemicals like carbon and hydrogen, which are key ingredients for life. The vents are full of tiny rock spaces where these chemicals could collect, mix, and react. The rocks may have helped speed up these reactions. Even today, deep-sea vents house rich ecosystems, even though it's dark there and the whole environment is kinda extreme. Scientists are still studying this idea. In 2019, researchers even created early life-like structures in lab conditions similar to these vents. Such an experiment showed that this theory could really work. Another idea is that life may have started under ice. Scientists believe Earth's oceans might have been covered in ice around 3 billion years ago. Sounds pretty severe, right? But the cold may have actually helped life get started. Many of the chemical building blocks of life, like simple amino acids, are more stable at low temperatures. In warmer water, these molecules break down quickly and are spread far apart. But when water freezes, it pushes those molecules together, increasing their concentration. This crowding makes chemical reactions more likely. So, let's say the molecules were packed closer together and were breaking down more slowly. In this case, they had more chances to link up and form more complex structures. Ice may have also acted like a protective blanket. It could shield the water from harmful ultraviolet radiation from the sun and from damage caused by meteor impacts. Another idea is that life didn't start on Earth at all. This theory is called panspermia, and it suggests that life came from space. Scientists know that big asteroid impacts can blast rocks off of planets. For example, rocks from Mars have been knocked into space before, and some of them ended up on Earth. Some researchers think tiny microbes might have survived inside space rocks during the journey. If that's true, life here could have started thanks to visitors from Mars or some other cosmic world. Others go even further and suggest that life could have traveled on comets or space dust from completely different star systems, hitching a ride across the galaxy. At the same time, even if panspermia is real, it doesn't fully solve the mystery. It just moves the question somewhere else. Instead of asking how life began on Earth, we'd need to ask, how did life begin anywhere in the universe?
It's been there for over 3 billion years, but now some of the Earth's oldest crust is falling apart. Today, our continents seem stuck in place, but over a long time, they've moved and shifted around a lot. It's all thanks to tectonic activity, which makes part of Earth's surface slowly slide around like pieces of a giant puzzle. Some of the most stable parts of these puzzle pieces are called cratons. Cratons are super old and strong sections of rock that form the roots of continents and keep them together. The North American craton is one of them. It makes up a big part of the United States, about half of Canada, and most of Greenland. Scientists have singled out about 35 of these big ancient cratons around the world. They mostly stayed in the same place for hundreds of millions of years because of how strong they are. But in 2014, they discovered that cratons might not be as indestructible as they thought. Some cratons had lost parts of their strong roots because of certain geologic processes and became thinner. It looks like cratons could become less stable if they go through more tectonic changes. In 2024, scientists at China University of Geosciences analyzed an ancient landmass called the North China Craton, or NCC for short. They wanted to learn more about how some of Earth's oldest rock regions can break apart. This process of cratons disintegrating is called decratonization. The NCC is so interesting to study because it has 3 main parts: the Western Bloc, the Eastern Bloc, and the Trans-North China Orogen, a zone that lies between the 2 blocks. Scientists found that during the Mesozoic era, the Eastern Bloc lost its deep ancient roots because of the strong Earth movements called tectonomagmatic events. So scientists wanted to see exactly how the processes in the mantle and the movements of Earth's plates led to the breaking down of the NCC. They created 4D models showing how the NCC's shape changed over time, including its surface shape, how its layers stretched, and the way earthquake waves moved through it. They found that a section of the tectonic plate slid beneath the craton and then began to roll back. This rolling and stretching made the strong rock thin out and eventually lose stability. All this started around 200 million years ago, back during the Jurassic period, when dinosaurs were rocking the world. The North China Craton isn't the only place where this decratonization process can happen. Other cratons, like those in North America, South America, and China's Yangtze region, may have gone through similar changes. Scientists say this shows how the continents on Earth have slowly changed and evolved over billions of years. And it looks like, when it comes to geology, there's no place that is 100% safe from changes, but it's no cause for alarm. You don't notice this, but our planet never stops moving and is perfectly normal. But sometimes, this movement still brings dramatic changes. In 2017, scientists made an official announcement that Zealandia can be called a new continent. The continental shelves of this mysterious continent are lying at a depth of around 3,280 feet below sea level. The nearest oceanic crust dives even deeper, at 9,800 feet below that. Geologists have gone deep down to collect rocks from the ocean floor. They've found that, unlike the nearby oceanic crust, which is made up of fresh basaltic rocks, the crust around New Zealand is a mix of ancient granite, limestone, and sandstone. All this screams continental crust. Plus, scientists have discovered a narrow strip of oceanic crust that separates Australia from the hidden land of Zealandia. It means these two are separate continents. 85 million years ago, Zealandia decided to break free from the supercontinent Gondwana. Millions of years later, the mighty Pacific Plate, the heavyweight champion of tectonic plates, decided to take a dive beneath Zealandia's continental crust. And that's how the root of Zealandia, that connection to its continental crust, broke off and went into the depths below. And that's not all the tectonic news from this part of the world. 120 million years ago, Australia and Antarctica were a single piece of land. They went their separate ways, but Antarctica didn't leave empty-handed. Today, there's an oceanic plateau in the Indian Ocean. Long ago, it was connected to another lost continent, the Kerguelen microcontinent. Scientists believe that it made a land bridge between India and Antarctica. To find out what it was like, we can look at a tiny archipelago in the southern Indian Ocean. These islands are all that is left of the ancient landmass. They have a cold climate and feature glaciers because they're so close to Antarctica. But in the past, the weather here must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that live in tropical regions today. Another lost and found continent isn't hiding in the ocean, but under Europe. It's called Greater Adria, and it collided with Europe and started to sink under it around 100 million years ago. Today it lies beneath Italy, Greece, and the Balkans. Its size and even shape match that of Greenland, the world's largest island. Greater Adria is no longer visible, but it left some clues. Part of it was embedded in the Alps. The other chunks are part of present-day Italy and Croatia, on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Great heat and pressure spread over tens of millions of years changed their structure. And that's when the limestone left the chat and the marble took its place. Greater Adria wasn't a solid piece of land like the big continent we see today, but more like a giant shallow shelf underwater. Over time, sand, mud, and other stuff settled on this shelf and slowly turned into rock. Greater Adria might have been a little like Zealandia or the Florida Keys, a chain of small islands sitting in a shallow sea. Above the water, there were probably lots of little islands and archipelagos, and beneath the waves, there were colorful coral reefs filled with marine life. If you lived back then and had a scuba tank, it would have been an amazing place to dive and explore. So, with all the things going on with the cratons, who knows? We could see a new continent in the future. Plus, studying the Earth's crust even deeper can change history as we know it. Scientists in Copenhagen have made an amazing discovery about the real birthplace of Scandinavia, and it's not where we thought. After studying sand and rock from remote parts of Finland, they found out that Scandinavia's roots actually came from Greenland, over 3.75 billion years ago. This means the area where Nordic countries are now is 250 million years older than the scientists had previously believed. And we now know, thanks to the tiny crystals called zircons found in Finnish river sands. When scientists look closely at their chemical makeup, they realize the age of crystals matched the rocks found in Greenland, not Scandinavia. They use special techniques to analyze elements like uranium, lead, lutetium, and hafnium, and discovered that Scandinavia's rocky base most likely broke off from Greenland billions of years ago. A small seed of land probably started drifting across the Earth's surface over hundreds of millions of years. This piece eventually settled where Finland is today. Over time, new layers of rock formed around this seed and slowly turned into the Scandinavia we see on maps now. The same study could help us rethink how the continents on Earth first formed. The most accepted theory is that the continental crust began growing right when the planet was formed. But new studies show that the signs of continents only started growing a billion years later. The scientists explain that Earth's continents may have begun as tiny seeds of ancient crust in different places. These seeds grew over time, forming the landmasses we know today. These ancient seeds aren't just found in Scandinavia, but also in Australia, South Africa, and India. Scientists aren't sure if all these seeds came from the same place or if they grew separately in different parts of the world. So there's still a lot to learn, and scientists need to keep digging to figure out if all these ancient seeds are related to each other.
A long time ago, a huge meteorite smashed into the Earth with a horrible destructive power. It was several times bigger than the one that wiped out the dinosaurs 65 million years ago. Luckily, there were no lives it could have taken, or else it would have been a real catastrophe. Now, scientists think it did leave behind a huge footprint, the massive Antarctica impact crater that is bigger than the entire state of New York. The location also has a gravitational Wilkes-Land anomaly going on. At first, scientists noticed something weird here when they measured Earth's gravity in that region: a strange gravity hole, or a negative gravity anomaly. Later, with better technology, they found something even weirder. There was a positive gravity anomaly inside that gravity hole, a spot with stronger gravity. This kind of structure, called a mascon, short for mass concentration, often shows up in places where giant space rocks or meteorites have slammed into the planet. When a meteor hits hard enough, it punches through the Earth's crust and shakes the mantle below. It can spring back up and leave behind a super dense plug of material, which causes stronger gravity right in the center of the crater. It's something like a frosty donut, with ice filling the gap and a dense center rising up from underneath. In 2018, scientists used advanced scanning techniques to study and map the Wilkes-Land meteorite impact in more detail than ever before. They saw that it wasn't a perfect circle, but more of a U-shape, and the northern part looked like something had broken it apart. It possibly happened when Australia split away from Antarctica about 35 million years ago. Some scientists even think you can still see parts of the crater in southern Australia today. This clue also supports the idea that the giant crater under Antarctica formed before the continents broke apart. There have been different ideas about what created this strange formation. Some said it might be a volcano or an eroded valley, or even a sedimentary basin. That is a place where sediments build up over millions of years. But many scientists now believe the most likely explanation is a massive meteor impact. It was possibly one of the biggest to ever hit Earth. A 2015 study even estimated the age of the crater as its size matches the kind of space rocks that smashed into Earth between 4.1 and 3.8 billion years ago. The Wilkes-Land meteorite impact was so powerful because the meteor that caused it could have been up to 30 miles wide. That's 4 to 5 times wider than the Chicxulub meteor that wiped out the dinosaurs 66 million years ago. Even that meteor was enough to cause massive destruction with wildfires, acid rain, tsunamis, and a climate crash that wiped out about 75% of all existing life. So it was lucky in a way that the meteorite that gave us the giant crater under Antarctica visited at a time when there were only microbes and no plants or animals on Earth. It didn't cause mass extinction or leave behind charcoal from ancient fires, but it may have changed the entire planet. Still, scientists haven't put the Wilkes Land anomaly mystery in the solved files because the crater is buried deep under Antarctica's thick ice sheet. It's hard to study up close. Scientists say we can't rule out the other ideas just yet, but if the meteor theory is right, then the Wilkes Land crater could be the largest known impact crater on Earth. So far, this title belongs to another contestant, the Vredefort crater in South Africa. Right now, the crater is around 99 miles wide, which is huge. But it's not as wide as the Chicxulub crater in Mexico, which is about 112 miles wide. But the Vredefort crater used to be way bigger, around 155 to 174 miles wide, before time and erosion wore it down. That means even though the Chicxulub impact was striking, the Vredefort impact was likely even more powerful, the biggest one we know of that hit Earth. According to the latest study, that asteroid was 12.4 to 15.5 miles wide and might have hit Earth at a speed of 45,000 to 56,000 miles per hour. It's important for science because knowing the real size of this impact helps us build better models to understand Earth's geology and how giant impacts shape planets, even beyond Earth. Measuring ancient craters is really tricky. Over 2 billion years, erosion wears away the edges and newer rocks form over the crater. That's what happened to Vredefort. Now, only small bits of the original crater rim are visible, and the rest is hidden under newer rock. To figure out its true size, scientists studied minerals like quartz and zircon found around the crater. These minerals still have fractures and shock patterns that show us how powerful the blast was. Wilkes Land anomaly isn't the only case on our planet where gravity is acting weirdly. For over 40 years, scientists were trying to solve a strange mystery in Canada. Parts of the country, especially around Hudson Bay, seem to have less gravity than the rest of the world. That means if you stepped on a scale there, you'd weigh just a tiny bit less than usual. Researchers first discovered this weird difference in the 1960s when they were mapping Earth's gravity. Gravity is linked to mass. The more mass there is, the stronger the gravity. And since Earth isn't shaped perfectly like a ball but is slightly squashed at the poles and bulges at the equator, it makes sense that its mass isn't spread out evenly. So, the first out of the two main theories to explain the Hudson Bay mystery has to do with magma. Yes, that super hot, gooey rock deep under our planet's surface. Magma constantly churns like boiling soup in a process called convection. As this magma moves, it can drag parts of Earth's crust down with it. That makes the area lighter, which lowers the gravity. The second area has to do with the Laurentide ice sheet, a massive glacier that covered much of Canada during the last ice age. This ice was up to 2.3 miles thick in some parts of Hudson's Bay. That's like stacking 10 Empire State Buildings on top of each other. Because it was so heavy, the ice pressed the land down like a thumb on a sponge. Even though the ice melted away about 10,000 years ago, the land underneath is still slowly bouncing back, kind of like a memory foam mattress after you get up. This slow rise is called glacial rebound, and it's happening at less than half an inch per year. Until the land fully bounces back, which could take 5,000 more years, it will continue to have less mass, and that means less gravity. Both of these theories are right. To figure this out, scientists used super advanced satellites, which floated around 300 miles above Earth for several years. These satellites flew in pairs and detected how far apart they were pulled as they passed over areas like Hudson Bay to measure tiny changes in gravity. When the front satellite passed over a low-gravity area, it drifted just slightly, and that change was recorded. Thanks to this research, scientists created detailed maps showing what Hudson Bay looked like during the last ice age. They discovered two huge bulges on the west and east sides, where the ice was thickest. And those spots have the weakest gravity today. The effects of this are still visible, and while sea levels are rising in most parts of the world, the land around Hudson Bay is rising so fast that sea levels there are actually dropping. Solving mysteries like this or the Antarctica impact crater anomaly gives scientists amazing insights into the past of our planet. And by understanding how past changes in temperature and geology affected Earth, scientists can predict how today's human activity can impact our future.
New Zealand is located in the Southwest Pacific, and it isn't just a country of mountains, the world's quirkiest creatures, and hobbit holes. But here's another cool fact. New Zealand sits on top of a hidden continent that's 94% underwater. That's right, just the tip of a sunken landmass more than half the size of Australia. And with sea levels rising, one question keeps, surfacing. Is it possible that all these remarkable creatures will need swimming lessons one day? Zealandia is a sprawling, drowned continent stretching from New Zealand to New Caledonia. This underwater region has mountains, valleys, and its own geological personality. But wait, how can something underwater be called a continent? Well, it turns out being underwater doesn't disqualify you from being a continent. It just makes you harder to spot. Most people think of continents as giant land masses you can walk on. But geologists don't define continents by what's above water. They define them by what they're made of. You see, most of Earth's crust is oceanic, thin, dense, and made of basalt. However, continents sit on continental crust, which is thicker, lighter, and much older. That's the case with Zealandia. Even though it's mostly submerged, it's composed of the same kind of crust as Australia or South America. It has mountain ranges, sediment basins, fault lines, it's not your fault, and even fossils that prove it once had forests and land creatures. Zealandia was above sea level during the age of dinosaurs, and while we haven't found a raptor-like theropod skeleton yet, there's no reason to believe we won't. So how was this discovery made? Since most of Zealandia sits about 1/2 to 1.5 miles underwater, it wasn't easy. We can't drain the region like a bathtub just to take a look. So the answer had to be technology. Scientists used satellites to calculate tiny changes in Earth's gravity to spot what was hiding under the waves. Yep, fun fact, there are satellites that can measure gravity now. For example, NASA's mission GRACE has 2 satellites that find small changes in Earth's gravity. It does this by measuring how far apart the satellites are as they move over different things. Scientists also use sonar to map out the underwater mountains and valleys in 3D. Finally, deep ocean drilling pulled up ancient rock, soil, and even land-based fossils from beneath the seafloor. Physical proof that this wasn't just the ocean floor. Not that scientists use all this tech in that exact order, like following steps on a checklist. It actually took decades of overlapping data from land, sea, and space to connect the dots. By the early 2000s, enough evidence had piled up that some geologists began to speak openly about a possible hidden continent. Still, it wasn't until 2017 that Zealandia was formally proposed as one, backed by clear geological criteria. And in 2023, after decades of mapping and research, Zealandia became the first continent to be fully mapped while almost entirely underwater. But why did it sink in the first place? Long ago, all of Earth's land was joined in a single supercontinent called Pangaea. Around 200 million years ago, I wasn't around then, it began to split apart. The northern half became Laurasia, which included what is now North America, Europe, and most of Asia. The southern half became Gondwana, made up of present-day South America, Africa, Antarctica, Australia, India, and Zealandia. About 85 million years ago, Zealandia broke off from Gondwana. It used to be connected to Australia and Antarctica, but when it split, Its crust became too thin and stretched out. That made it less sturdy and more prone to sinking. You can think of it like a piece of ice that floats lower in the water after it breaks off a bigger chunk. Over time, tectonic forces, like plate movement and the loss of its deeper support, caused most of it to sink. It didn't just sink because it was weak, but because it was pulled down by Earth's shifting plates. It settled lower into the mantle because it didn't have the structure to stay higher up. Today, only the highest ridges, like New Zealand, remain above water. That's kind of cool to think about. If Zealandia had never sunk, Wellington would be somewhere up to 9,800 feet high. That's higher than Aspen, Colorado. Now, we know New Zealand is packed with weird and wonderful animals. Birds that can't fly, bugs that glow, sheep that outnumber people. But what about its underwater world? Is it just as special? Actually, yeah. And honestly, maybe even cooler. Zealandia's sunken edges are home to marine life that's just as unique and isolated as the wildlife on land. We're talking thousands of species that evolved in near total obscurity, tucked away on a submerged continental shelf. Think of it as Earth's secret underwater lab. This is all thanks to diverse temperatures and over 50 different habitats in coastal regions alone. Take fish, for example. Some are delicious. But around 300 species found in these waters are endemic, meaning if you don't live near New Zealand, you'll never see them. This cute little fish is called southern lemon sole, and it stands out with its asymmetrical, pancake-like body and the odd habit of burying itself almost completely in sand, leaving just its eyes poking out. And the deeper you go, the stranger it gets. Zealandia's underwater slopes and canyons have creatures that feel like they were designed during a power outage at the Evolution Lab. My favorite is carnivorous sponges. Yep, sponges that eat meat. There are also sea daisies, which are small, flat, round creatures that don't seem to fit neatly into any specific family of animals. Scientists have discovered these unique little animals hanging onto sunken wood more than half a mile deep in the ocean. They're so unusual that researchers almost created a separate category just for them in the echinoderm family tree, which includes other marine life like starfish and sea urchins. And then there's the New Zealand scamping, a lobster-like crustacean that lives in muddy burrows on the ocean floor. This creature snacks on jelly-like blobs, ghost sharks, and pretty much anything that floats by. Even seaweeds are unique there, although they're not as cool as predatory sponges. Oh, by the way, an interesting fact about the regions close to New Zealand is that they hide active underwater volcanoes. The most famous one is called Brothers Seamount. It's located about 210 miles northeast of New Zealand. It's a massive underwater volcano with a crater at the top, constantly bubbling with heat and chemicals. What makes it fascinating is that these vents, called black smokers, support ecosystems that don't rely on sunlight. Instead, bacteria use chemicals like sulfur to produce energy, a process called chemosynthesis. These bacteria form the base of a food chain that includes species like tube worms and deep-sea shrimp, which are adapted to survive in extreme heat, pressure, and complete darkness. That's not typical for most ocean life, which depends on photosynthesis and stable conditions. Brothers Seamount is also loaded with metals like copper and zinc, making it scientifically valuable and, potentially, commercially tempting. So it goes without saying that Zealandia is incredibly important to scientists. It offers a unique window into Earth's geological and biological history. It's like a time machine and a natural lab that helps scientists piece together Earth's history. So, in the end, could New Zealand end up underwater due to water levels rising naturally with each century? If you're imagining New Zealand slowly disappearing beneath the waves, like a real-life Atlantis myth, don't. Even with sea levels rising, that kind of full-on submersion just isn't likely, even in the worst-case scenario. New Zealand's tallest point, Mount Aoraki, stands over 12,000 feet above sea level. For the ocean to cover that, it would need to rise by more than 2 miles. And unless Earth suddenly turns into a water balloon, That's not happening. Okay, but what about sinking? Could it sink like Zealandia did? Zealandia sank because it had a thin, stretched-out crust. It didn't have the strength to stay up. But New Zealand? It's sitting on the sturdy, lifted backbone of the continent. In fact, thanks to tectonic plate collisions, parts of it are actually rising every year. And not just rising, shaking too. Zealandia has active tectonic plate boundaries, which is why the region gets so many earthquakes and volcanic events. So, while Zealandia may be almost entirely underwater, New Zealand is holding its ground, literally. In other words, the Kiwi won't need swimming lessons anytime soon. Around our planet, there's an invisible magnetic shield that blocks solar radiation. But it isn't spread evenly. One patch is thinner and it has a name, the South Atlantic Anomaly. On the ground, we're fine. Up in orbit, satellites get glitchy as they fly through charged particle storms. And lately, that weak spot looks like it's changing shape. It's spreading out, and some maps even show it splitting into two. So why is that happening and what does it mean? Well, to understand the weak spot, we have to go deep below to the core of the issue and the planet. Around 1,800 miles down, Earth's outer core is a boiling ocean of molten iron and nickel. There, the temperature can rise to more than 10,000 degrees Fahrenheit. As that liquid metal moves, it generates electric currents, and those currents create our magnetic field. Now, without the field, the sun's charged particles would slam straight into our atmosphere and start stripping it away. But this magnetic field isn't a smooth, perfect bubble. It's lopsided and tilted. It's constantly shifting. Beneath Africa, some magnetic lines bend the wrong way, back toward Earth instead of out into space. Scientists call these reverse flux patches, and they weaken the field above them. Right over that weak spot is the SAA, the South Atlantic Anomaly I mentioned earlier, and it's changing fast enough that we can watch it shift over just a decade. Scientists know this because of an ESA mission called SWARM. It's 3 satellites constantly, swarming, and mapping Earth's magnetic field in detail. Their maps show that the anomaly has been spreading since the mid-2010s. It's getting weaker and starting to look like it's splitting in two. Now, back down here, we're protected by the atmosphere, but we are still affected indirectly if satellites start acting weird. Most of the satellites we rely on are in low Earth orbit, a few hundred miles up. Over the SAA, the radiation belts droop closer to Earth than usual, so when a satellite passes through, it's like driving through a stretch of space that's far more charged than normal. A single burst of particles can flip tiny bits inside a computer chip. It can corrupt a sensor for a moment or trigger a reset. It can force the satellite into safe mode, where it shuts down anything sensitive to survive. Many satellites cross the SAA multiple times a day, which means each pass is another roll of the dice. Even Hubble has to respect it. Hubble is one of the most famous space telescopes that's been taking those insanely sharp pictures of galaxies, nebula, and weird deep space stuff for decades. But when it's about to fly through the South Atlantic Anomaly, it basically goes, no. It stops certain observations and shuts down its most sensitive detectors until it's in the clear again. The satellite is too valuable, and it's not worth taking chances and losing it. Which is exactly what happened to a high-tech Japanese satellite. In 2016, Japan launched Hitomi, a next-gen X-ray space telescope built to study the hottest and craziest objects in the universe, stuff like exploding stars and monster black holes. It was supposed to run for years. Instead, a problem that showed up when it was passing through the SAA kicked off a cascade of attitude control failures. The spacecraft ended up spinning, breaking apart, and the whole mission was lost just weeks after launch. That's not a glitch. That's a multi-year science plan worth billions of dollars lost in just a month. So why does SAA seem to be growing, and why would it split into two? Deep under Africa, Earth's core is like a giant pot of liquid metal. The swirls can change shape over time. Imagine you're holding a strong magnet under a table, and on top of the table there's a thin metal sheet. If you slide the magnet around underneath, the metal above shifts too. If you use one magnet, you get one dent. If you move it or add another magnet nearby, the dent stretches or splits into two. The moving liquid iron deep below acts like shifting magnets. When the flow pattern changes, it creates weak spots in the magnetic field. If one weak spot spreads underground, the dip above it spreads too. If two weak spots form close to each other, that single sag at the surface can split into two dents right next to each other. And that's where this stops being cool Earth science and starts being a problem. Because if the magnetic field can rearrange itself that much in a decade, well, anything we rely on in orbit has to deal with it. But is the South Atlantic anomaly just one local weak spot we have to work around? Or could it be an early hint of something much bigger, like a pole reversal? You see, Earth's magnetic poles are not locked in place forever. North and South have swapped many times before. Magnetic North can drift, weaken, and eventually trade places with magnetic South. Wait, what does that actually mean? Well, it means those football fans who are gathering in the North Stand now have to start cheering from across. But, jokes aside, the planet is not flipping around or becoming the upside-down world. The liquid iron shifts its flow pattern, and the whole magnetic layout reshuffles. Just like every other natural process, it doesn't happen all of a sudden. The field can weaken first, it can break into uneven patches, it can look messy for a while before it settles again. That problematic stage is what would matter most for satellites. Because we know this happened before. When hot lava cools into rock, tiny bits of metal inside line up with Earth's magnetic field and get stuck pointing that same way. Much later, scientists can read that direction like a compass arrow trapped in stone. One famous case is the Lachamps event about 41,000 years ago. Hey, I wasn't around then. But for a while, Earth's magnetic field got much weaker. Then it partly flipped, and then it bounced back. The simplest idea is that the liquid iron deep inside Earth started flowing in a different, unpredictable way for a while. So the magnetic field got scrambled. A pole reversal is the biggest version of this scramble. The South Atlantic anomaly is a smaller, local version. Both happen because the liquid iron flow deep inside can change. The SAA does not mean a reversal is definitely coming. It just shows the magnetic field can get uneven when the stuff underneath shifts. While the anomaly is changing, there's another space problem that can hit way beyond that one spot in the Atlantic: geomagnetic storms. The Sun sometimes launches a huge cloud of superhot gas with its own magnetic field. It's called a coronal mass ejection, or CME. Some of these clouds race outward at over 1,000,000 miles per hour. If one of them is aimed at Earth, it slams into our magnetic shield and shakes it. That shaking dumps extra energy into the space around Earth. It scrambles radio signals, messes with GPS accuracy for a while, and, in extreme cases, even pushes electric currents into long power lines on the ground. Oh, and they also cause breathtaking auroras. Back in March 1989, a major geomagnetic storm triggered a Quebec blackout that left 6 million people in the dark for hours. Another example was in May 2024, when a strong geomagnetic storm disrupted certain satellite and radio signals, forced some airlines to adjust routes, and pushed auroras much farther south than usual. Solar storms don't hit at the same strength all the time. The Sun goes through an activity cycle that lasts about 11 years. During the busiest phase, it fires off more flares and more giant clouds of charged particles, so strong geomagnetic storms become more likely. Right now, we're in one of those busier stretches. So the odds of rough space weather are higher than they were a few years ago. But the bigger reason it feels scarier is how modern life works. We lean on satellites and power grids more than ever. So a storm that used to be a cool aurora night can now mean signal glitches, GPS hiccups, rerouted flights, grid strain, and a lot of expensive fixing.
There's something strange hiding 1,800 miles down that's helping keep you and me alive. I'm talking about two massive structures beneath Africa and the Pacific Ocean that might be controlling Earth's magnetic field. Our secret heroes are rocks. Special rocks, actually. They're located right at the base of Earth's mantle, and each one is wrapped in a ring of cooler rock that runs from the North Pole to the South Pole. They are extremely hot and huge, about the size of a continent, but these structures are not like secret land masses. Think of them like blankets that sort of trap the heat. And these two big guys may have been warping Earth's magnetic field for millions of years. We'll get into that, but first, let's talk about this famous invisible force around our planet. Earth's magnetic field forms huge magnetic loops, almost like there's a giant, slightly tilted bar magnet inside our planet. It's generated in Earth's outer core. So, at the very center of Earth, you have the inner core, a super dense, solid ball that's insanely hot. That heat pushes outward into the core, a layer of liquid iron. As the liquid iron heats up, it starts to move, swirling and churning. Then those motions create powerful electric currents. This is what we know as geodynamo, a process that powers Earth's magnetic field and takes an insane amount of energy. And we love this field, okay? Because it's like a shield. It protects Earth from dangerous solar wind and cosmic radiation. Without it, yes, me and you and everyone else, we couldn't live on this planet. Over time, the field changes. Its strength goes up and down, and Earth's magnetic north and south poles slowly drift. They can even flip, but that usually takes a long time, like 300,000 years or so. And the thing steering Earth's magnetic field might be those two rock structures I mentioned earlier. So the study started with one big question. How has Earth's magnetic field changed over millions and millions of years? Thankfully, scientists can tell what it looked like in the past, thanks to rocks. Yep, some minerals have this weird ability to lock in the direction and strength of the magnetic field as they cool. That creates a record that can last for hundreds of millions of years. These hidden clues in rocks have helped scientists learn a lot about Earth's magnetic field, like its age, for example. Evidence suggests it may be at least about 4.2 billion years old. That means it's been around for almost as long as the planet itself. And it also means it's much, much older than Earth's inner core. Now you might be confused, because earlier I said the core is what generates the field, and that's true today. But back then, before the inner core formed, something else may have powered the field, like magnesium oxide. The idea is that when a giant impact formed the moon, Earth got so hot that magnesium oxide likely melted and mixed deep inside the planet. Then, as Earth slowly cooled, that material could start coming back out. That process may have helped keep the magnetic field running. But over time, Earth may have used up most of that magnesium oxide. And researchers think that's why the magnetic field almost collapsed about 565 million years ago. Yeah, we were this close to becoming a lifeless planet, like Mars or Venus. Thankfully, around that time, Earth's inner core began to form, and that gave the planet a new power source. It helped restart the geodynamo and rebuild the magnetic shield we still have today. More recently, scientists decided to take another look at our field's past. This time, they went back 265 million years. They took the magnetic signatures locked in rocks and recreated Earth's ancient magnetic field using computer simulations. And they found something interesting. In some places, the top of the outer core is much hotter, and those hot zones sit right under those two strange, massive deep rock structures. We can think of them as huge blankets, somehow trapping heat underneath. It's like they don't let heat escape as easily from below. The result is that heat builds up differently under those mantle regions. Instead of a smooth, even temperature spread, you get sharp temperature contrasts in the outer core. And that's a big deal. Until now, scientists assumed the boundary between the mantle and the core, right above the liquid iron, was pretty uniform. Kind of like an oven, heating things nice and evenly. But these new findings challenge that idea. Instead of an oven, it might be more like a stovetop with uneven burners. In hotter regions, you might think the iron moves faster, right? Like the liquid would rush. But no, it's the opposite. In the hotter zones, the liquid iron seems to slow down. In some spots, it may even almost stall, like it's getting stuck in a warm, sticky area. But under the cooler parts of the mantle, it's a different story. The liquid iron can flow more energetically. Think of a big pot of thick soup on a stove that isn't heating it evenly. In some places, the soup gets really hot, while in other places, it stays cooler. Where it's extra hot near the top, the soup ends up heavy and sluggish, but in cooler spots, it can circulate more easily. So instead of one smooth swirl through the whole pot, you get uneven motion. This uneven movement deep inside Earth leaves fingerprints. As liquid iron moves, it helps run Earth's magnetic field, almost like a natural generator. Actually, a messy one, because while some parts of Earth's magnetic field have changed dramatically over time, other features have stayed surprisingly stable for hundreds of millions of years. In other words, the mantle is quietly shaping how the core moves, and the core's motion, in turn, shapes the magnetic field we live inside every day. That changes everything. Because for a long time, scientists have treated Earth's magnetic field like a simple, steady bar magnet pointing along the planet's spin axis. I mean, it's almost like there's a giant bar magnet inside the planet, lined up with the way Earth spins. That's why a compass usually points north, no matter where you are. It's not perfect, but it's close enough most of the time. But these new results suggest deep structures in the mantle have been bending or warping the magnetic field in a long-lasting way. And that could help explain some really weird behavior on Earth. You see, every once in a while something unusual happens. The magnetic field weakens and gets messy. Instead of acting like one clear magnet with a north and south pole, it can split into several weak mini-poles. Scientists call this a multipolar state. These events have happened many times in Earth's long history, but they are rare. And the good news is that the magnetic field doesn't stay messy for long. It usually builds itself back up and becomes strong and simple again. And what they've just found out is that those huge deep rock structures inside the Earth seem to help with this recovery. They act like stabilizers, helping the magnetic field return to its normal organized shape after it weakens. This could change how we look at a lot of Earth's past. These findings might help scientists piece together how continents were arranged long ago. For example, it could help us better understand how the supercontinent Pangaea formed and later broke apart. It could also help clear up long-standing questions about ancient climate, early life, and even how some natural resources formed. But the conclusions of this study aren't 100% certain yet, and more research is still needed. We continue to have a lot to learn about these hot, massive rock structures deep inside Earth. Still, if this idea holds up, we may have a lot to be thankful for, because these rocks might be helping keep Earth's magnetic field stable. And that stability helps protect all of us.
You know, we've all begged for just 1 extra hour in the day. Actually, 2 hours would be better. Well, scientists have good news and bad news. The good news is that our planet is heading toward a future where a day could last 25 hours. The bad news is that eventually, the same physics that makes the day longer will also get rid of our planet's rotation, literally freezing Earth in time. Meaning endless days and nights and oceans fleeing to the poles, all while the atmosphere turns into a relentless planet-wide storm. Uh-oh. Now, back when the Earth was just a massive, messy cloud of dust and gas, gravity started pulling everything toward the center. As all that debris smashed together, it started to swirl, like water rushing down a drain, but on a cosmic scale. That spin caused a momentum. Since space is a vacuum, there was no air to slow us down. Earth just kept spinning, and that spin became a day. One full rotation takes about 24 hours, and that's the rhythm we've known since we started recording time. But the thing is, we adopted 24 hours as a close estimate. In truth, a day is never exactly 24 hours long. Now, basically, Earth keeps spinning, but it's constantly losing tiny bits of speed. That's mostly because mass keeps moving around. Think of it like a figure skater. If they pull their arms in, they speed up. If they put them out, they slow down. Earth does the same thing, except without arms. When the 2011 earthquake hit Japan, it shifted the ocean floor so violently that it pulled Earth's mass inward, instantly shorting our day by 1.8 microseconds. Conversely, as glaciers melt and water rushes from the poles to the equator, Earth's arms are spreading out, causing us to drag. We're not just sitting on a big rock. It's like we're on a wobbly spinning top that moves every time something heavy happens on it. Most days end up being a few milliseconds longer than 24 hours. We can't feel this, but atomic clocks can measure it. Over long periods of time, those milliseconds add up. And as they do, the length of a day slowly increases. That's how a 24-hour day starts drifting toward 25. To check this, scientists pulled together nearly 3,000 years of sky records. Thousands of years ago, people carefully recorded eclipses. It was a scary event. Kings, priests, and astronomers wrote the exact time and location when the sun vanished. Those records survived on clay tablets, scrolls, and manuscripts. For the sky to go dark, the sun, earth, and moon must line up perfectly. If the timing is off by even a second, the shadow falls on the wrong part of the world. Today, astronomers know the moon's movements with incredible precision. They actually bounce lasers off mirrors left on the lunar surface to measure its orbit. That's why, in theory, we should be able to rewind the past like in a YouTube video and see every ancient eclipse exactly where history records it. But when scientists tried that, the moon showed up too early, or too late. The shadow wasn't where the record said it should be. The puzzle only solves itself when you realize one thing: Earth used to be a little faster. When researchers adjust Earth's rotation to be slightly quicker, everything snaps into place. In other words, Earth was spinning a little faster in the past, and these eclipse records show it. On average, this translates to a day increasing by about 1 to 2 milliseconds every 100 years. That's 1,000th of a second. You'll never notice it. But over time, those tiny bits stack up. About a second every 10,000 years. That means we are roughly only 200 million years away from having that one additional hour of sleep. So the good news turns out to be only meaningful for future Earthlings. But why is this actually happening? Well, the answer is the moon. Its gravity grabs Earth's oceans and stretches them into huge tidal bulges. But because Earth spins much faster than the moon moves around us, those bulges don't sit neatly under the moon. They get dragged slightly ahead as the planet rotates. That means the oceans are constantly being dragged across the planet, rubbing against the seafloor and the continents. That rubbing creates friction, and friction is a thief. Where there's friction, there's heat. So the moon slowly turns Earth's spin into heat that spreads through the oceans and into space. And once that energy is gone, it's gone for good. Since there's no visible cosmic creature to push Earth back up to speed, day after day, the moon acts like a slow, steady brake, stretching our days little by little and drifting farther away as it does. Yes, as much as we used to fear that the moon would collide with Earth one day, it's actually going in the opposite direction. All that transfer of energy that's happening between Earth and the moon is slowly pushing our satellite further away, approximately 1.5 inches per year. We know this because during the Apollo missions, astronauts left mirrors on the moon's surface, and today scientists fire lasers at those mirrors and time how long it takes the light to come back. However, even though we are slowly pushing the moon away, don't panic. It's not packing its bags just yet. At the current rate, It would take tens of billions of years for the moon to retreat significantly, but it will stick around long enough to witness and maybe even cause the end of all ends, so to speak. The same braking force that is slowing us down now could eventually push Earth into a state called tidal locking. This has actually already happened to the moon. You know how we never see the dark side of the moon from Earth? Well, that's because Earth's gravity grabbed the moon eons ago and forced its rotation to stop relative to us. Well, if you give it enough time, the universe could return the favor. If Earth slows down enough to match its orbit around the Sun, the cycle of day and night will disappear. We could turn into what astronomers call an eyeball planet. Because the Sun would just hang motionless in the sky, the side facing it would turn into a blistering scorched desert. That's the pupil of the eye. The side facing away would freeze into a massive white shell of ice, the white of the eye. The only spot where life could hang on in this area is called the iris, a narrow strip caught between the crazy hot day and the frozen night. But even that wouldn't be a dream come true. You'd have super hot air on one side smashing into freezing air on the other. So this zone would be hit by insane hurricane-level winds whipping across the surface. Also, without Earth's spin shaping the oceans, water would slowly migrate away from the hot regions and collect in colder zones, reshaping coastlines and continents entirely. The planet wouldn't just have longer days. It wouldn't even look like Earth anymore. But here is the bright side. We will actually never see this happen, and neither will our descendants, at least not while watching from nearby. The math says it would take about 50 billion years for Earth to stop spinning and turn into that frozen eyeball fully. But our Sun doesn't have that kind of time. In about 5 billion years, the Sun will run out of fuel. It will expand into a red giant, swallowing the inner planets and likely vaporizing Earth entirely. Bye-bye! So, while Earth is slowing down, it will never actually get to zero. We won't end as a frozen, motionless rock. We'll end as we started, space dust. By the time Earth ever stops spinning, humans certainly won't be watching from the solar system. We might be scattered across the galaxy, living in space, or not even human anymore. Some of us could live inside massive structures built around stars, capturing their energy instead of orbiting them. Others might drift near black holes, using their gravity and energy in ways we barely understand today. Entire civilizations could exist as uploaded minds, connected through a galaxy-wide network, living in simulations instead of physical worlds. Well, wherever we are, Earth would just be an old planet concluding its story.
Which bridge do you think truly changed our world? The Golden Gate, Tower Bridge, or the Brooklyn Bridge? Here's a hint. This one wasn't built by humans. It was crafted by nature over millions of years. Its width ranges from 30 to 120 miles, stretching approximately 400 miles in length. That sounds enormous, but if you zoom out far enough, you'll see a narrow land strip connecting North and South America. This is the Isthmus of Panama. The natural land bridge reshaped global weather patterns, transformed ocean biodiversity, brought parrots to North America, and set off countless chain reactions that changed life on Earth forever. By the way, have you ever heard of the butterfly effect? It shows that even a tiny change in the environment here and now can trigger unpredictable consequences somewhere else, sometime later. For example, a butterfly flapping its wings could set off a chain of thousands of events that might eventually trigger a hurricane on the other side of the planet. Similarly, the formation of the Isthmus of Panama acted like a planetary butterfly, sending ripples across ecosystems, oceans, and climates worldwide. Let's break down how this happened, step by step. Approximately 100 million years ago, South America separated from Africa and gradually drifted toward North America. Initially, the continents were completely separated. There was no land corridor between them. Water with marine life flew freely between the North Atlantic and North Pacific. But a few million years ago, a massive tectonic event reshaped everything. Seismic activity caused the tectonic plates to shift, collide, and wedge against one another. When plates collide, they form mountains. When they drift apart, they create ocean basins. The Isthmus of Panama emerged when the Caribbean plate wedged itself between the plates carrying North and South America. This wasn't a quick process. It was a catastrophic long-term event that involved the uplift of the seafloor and volcanic eruptions. Peaks of volcanoes eventually emerged above the water. At first, there wasn't a continuous bridge, just volcanic islands with ocean currents racing between them. Over millions of years, sediments carried by ocean currents gradually filled the gaps, eventually forming a complete land bridge. Imagine it like a clogged sink. Scraps of food slowly accumulate over the drain and eventually block the flow. The difference here is that no one could unclog the land bridge, and so the process continued until the continents were connected. This was the start of the butterfly effect. The formation of the isthmus had profound consequences on the global climate. When the ocean passage closed, currents shifted dramatically. Warm equatorial waters from the Gulf of Mexico began flowing into the Atlantic along North America's coast, giving birth to what we now call the Gulf Stream. This current altered the distribution of heat and salinity in the Atlantic, influencing weather patterns worldwide. These changes influenced the thermohaline circulation, the system of ocean currents driven by differences in temperature and salinity. Salty, warm water in the Atlantic started moving differently, causing shifts in nutrient distribution and altering habitats for countless marine species. Some survived the new conditions, others vanished, but these changes also set the stage for global cooling. Scientists believe the Gulf Stream, reshaped by the isthmus, carried more moisture toward the Arctic. When moisture reaches a cold region, it freezes into ice. Massive volumes of water transformed into giant glacial sheets. The more ice accumulated, the colder the planet became. Not because the ice is cold, but because it reflects sunlight back into space, preventing heat from warming the Earth's surface. This warm reflection intensified cooling, influencing climates across continents. Anyway, this is only a theory, but it shows a good example of the butterfly effect triggered by the Isthmus of Panama. Now, let's see what happened underwater during those events. The once free-flowing waters between the Pacific and Atlantic were cut off. Marine species that had previously migrated freely between oceans became geographically isolated, forcing populations to evolve separately. Shifts in water temperature, salinity, diet, and nutrient availability drove a divergence in species across the oceans. For example, snapping shrimp of the genus Alpheus, which once traveled freely between the Pacific and Atlantic, were split into separate populations. They may look nearly identical to the naked eye now, but genetically, they became distinct species. This didn't produce extreme transformations, like turning a shark into a seahorse, but it permanently altered ocean ecosystems and the paths of evolution. The most dramatic changes, however, occurred on land. Over millions of years, South American animals migrated north, while North American species moved south. This mass migration was so significant that scientists named it GABI, the Great American Biotic Interchange. For instance, Virginia opossums and certain porcupines in North America arrived from South America. Conversely, some horses, bears, llamas, and raccoons made the journey south. It seems like a simple relocation of animals, but this migration reshaped ecosystems and led to the extinction of numerous ancient South American species. This continent had been isolated for millions of years, and this allowed unique species to thrive in a warm, humid, and relatively competition-free environment. When these animals moved north, they encountered fierce competition and harsh climates. Many didn't survive. Those that did were remarkably well adapted. Among the survivors were armadillos, sloths, anteaters, and other creatures. Why these species thrived is still debated, but factors such as protective armor, strong claws, and slow metabolism likely played a role. Armadillos, for example, didn't need to outrun predators. They can simply hide under their armor. conserving energy. Their slower metabolism made them less dependent on scarce food sources, giving them an edge in a new environment. North species that migrated south included American alligators, coral snakes, dwarf squirrels, tapirs, otters, skunks, and foxes. Many of these animals established populations that continue to exist in Central and South America today. The isthmus didn't just mix species between continents, it also became home to countless unique creatures: boas, iguanas, electric rays, jaguars, a wide variety of frogs, and the resplendent quetzal exists in Central America thanks to the emerging of northern and southern ecosystems. Plants also took advantage of the new connections, spreading their seeds across previously isolated lands. Now, let's turn to people. How did the isthmus change our lives? You've probably heard of the Panama Canal. This human-made waterway cut through the isthmus, connecting the Atlantic and Pacific Oceans and transforming global trade. Without it, ships would have to sail around the tip of South America, consuming far more fuel and time. The canal shortened these journeys dramatically, acting almost like a portal for international commerce. This Panama Passage is one of the most significant human-made maritime structures in the world. Every year, around 300 million tons of cargo pass through it, roughly 5% of all ocean freight. The idea to cut a passage through the isthmus dates back to the 16th century. However, construction was delayed by conflicts between countries. In the late 19th century, excavation began, but early efforts were plagued by poor planning, mismanagement, epidemics among workers, and corruption that drained investor funds. The United States eventually took over the project. By 1914, the first ship passed through the canal, and in 1920 it was officially inaugurated, completing one of humanity's most ambitious engineering feats. It seems that before the 20th century, people were just rounding South America to deliver heavy goods. Imagine how dangerous such a voyage would be without modern means of navigation. But actually, they used the land. Sailors arrived at one side and unloaded the cargo. Then they transported it through the isthmus and brought it to the other side, where new ships awaited them. It was probably a long and dangerous journey, but still, it was more profitable and easier than a water bypass of the entire continent. So next time you look at the world map and notice this tiny strip of land, you'll remember how it shifted climates, transformed ocean currents, created unique ecosystems, triggered massive migrations of plants and animals, and revolutionized global trade. The butterfly effect of this narrow bridge is still happening now. Earth has one huge connected global ocean that covers about 71% of the planet's surface. And since it's all water, it could make sense that it's the same height everywhere in the world, right? Strangely, at the Panama Canal, the Pacific Ocean is sitting higher than the Atlantic. And it gets even stranger. In the Indian Ocean, there's a massive gravity low where sea level sits dozens of feet lower than the global average. Let's figure out the mystery of the Pacific Ocean first. The difference in height between it and the Atlantic is, on average, about 8 inches, and that's a carefully measured long-term difference. We aren't talking about waves or high tides here. The thing is, water expands when it's warm. The Pacific is usually warmer than the Atlantic, so its water kinda takes up more space. Salinity matters too. The Pacific is less salty in many regions. Fresher water is less dense, and less dense water sits a little higher. Then there are currents and winds. Strong trade winds, which are winds that blow from east to west just north and south of the equator, push massive amounts of water westward across the Pacific. That water piles up along continental edges. But probably the most important and unexpected factor is that gravity isn't the same everywhere on Earth. Continents, islands, and even underwater mountain chains pull on the ocean's surface. And the ocean actually follows Earth's uneven gravity field, not its geometric shape. Because of all this, global sea level can vary by up to 10 feet from one region to another. Now imagine how difficult it was to fight gravity and build a canal connecting these two oceans. Engineers had to consider the Pacific-Atlantic height difference while working on the construction of the Panama Canal. Surprisingly, it turned out that it wasn't the main obstacle. There were much bigger problems, but we'll talk about them a bit later. So one day, people looked at Panama and thought, how hard could it be to dig a canal and connect two oceans? Very hard. The surface of Panama is steep, muddy, rainy, and unstable. So instead of digging in a sandbox, building a canal would be carving a trench through a wet, collapsing mountain. Engineers wanted a sea-level canal cut straight across so ships could cruise through without any locks or lifting. But Panama wouldn't cooperate. Every time workers dug into a hillside, the dirt slid right back down. During the rainy season, rivers flooded everything, burying the equipment. Then workers started getting sick constantly. At the time, scientists didn't fully understand that mosquitoes were spreading diseases, so outbreaks were literally wiping out crews. Thousands of people lost their lives. Eventually, the whole project collapsed, both financially and physically. Years later, the US tried again, but this time they decided to take nature into consideration. Instead of digging straight through at sea level, they built a giant water elevator system. It works like this. Ships enter huge chambers and the gates closed. Next, water fills in and the ships get lifted about 85 feet. That's basically the height of an 8-story building. That's where a huge artificial lake is. The ships cruise across that lake, then get lowered back down on the other side. It's like moving ships over a hill using bathtubs the size of skyscrapers. Anyway, what's the deal with Earth's gravity? Forget the idea that our planet is a perfect ball. Imagine it as a lumpy and spinning potato. The middle bulges out a bit because of the planet's rotation. The crust isn't uniform either. The density below the surface changes constantly. Some areas are heavy and dense, others light and floaty. That's what actually shapes gravity across the planet. Now, it's time for the geoid to enter our story. It's the shape the ocean would have if it were shaped only by Earth's gravity and rotation, with no waves, no winds, and no tides. In other words, if it just floated freely across this lumpy potato. Over dense areas, gravity pulls harder, so the water piles up. Over lighter areas, gravity is weaker, and the water sags. For example, there's a weird spot in the Indian Ocean where gravity is actually weaker than normal. And because of that, the sea level there sits more than 328 feet lower than the surrounding ocean. That's like water dipping down the height of a 30-story building. It forms a massive circular depression covering about 1.2 million square miles. It's officially called the Indian Ocean Geoid Low. Scientists first noticed it in 1948 during a gravity survey from a ship and have been puzzled about this phenomenon for years. Why would Earth's gravity be weaker in one patch of ocean? Finally, researchers think they might have figured it out. Deep under that part of the ocean, huge plumes of hot magma may be rising from the mantle, kind of like slow-mo lava blobs pushing upward from thousands of miles below. These upwellings can shift mass inside the planet, and when mass shifts, gravity shifts too. Lean mass underneath means a slightly weaker pull, and the ocean water sinking lower in that spot. To test the idea, researchers ran massive computer simulations. They basically rewound Earth's history back 140 million years to see how the region evolved. And guess what? Their models point to the breakup of an ancient ocean that no longer exists. Apparently, tectonic plates moved and pieces of crust sank deep into the mantle in that region. They likely disturbed the material below, setting off those magma plumes. So this gravity hole isn't a hole in the water. It's a dent in Earth's gravity field, caused by deep, planet-scale plumbing problems that started millions of years ago. The depression is so extreme that it influences ocean currents, sea level readings, and even satellite paths. That's how strong these mantle processes are, even millions of years after all that tectonic drama. The big question now is, will the Indian Ocean Geoid Low ever go away, or is it here to stay? Scientists aren't 100% sure. It all depends on how the masses inside Earth move around over time. our planet's mantle isn't solid. It's constantly shifting, rising in plumes and sinking in slabs. These slow and deep motions can either keep the gravity low intact for millions of years or eventually smooth it out. Think of it like a giant slow-moving lava lamp under the ocean. Over a few 100 million years, the blob could shift enough to erase the dip, or not. In any case, the study gives some interesting ideas and might push experts to dig deeper. The older research only modeled sinking cold slabs in the mantle. Now, the simulations include hot, rising magma plumes. They were probably key to forming the low in the first place. But there are also missing pieces in the simulation. For example, the famous Réunion hotspot, a massive mantle plume that erupted around 65 million years ago, forming the Deccan Traps across India. That eruption dumped lava over half of India. It was one of the biggest volcanic events in Earth's history. Without that plume in the simulation, some of the geoid predictions might be off. There are also mismatches between the model and reality. The predicted shape of the Earth's surface doesn't perfectly match actual measurements, especially in the Pacific, Africa, and Eurasia. The researchers say there's about an 80% correlation, which is quite good, but not perfect. Unfortunately, the simulation can't capture every detail yet. The lead researcher explains why. We just don't know exactly what Earth looked like millions of years ago. Plates were shifting, oceans were moving, and continents were crashing into each other, so there's a lot we just don't know. The models can only give us a rough idea of what the past looked like. Still, despite the small errors, the main takeaway is the following. The Indian Ocean geoid low is massive and shaped by deep mantle plumes and ancient tectonic events. It might change over the next hundreds of millions of years, or it might stick around. It's also a reminder that Earth is not a perfect smooth ball we like to imagine. Earth isn't a perfect ball, we know that. But the real mystery is miles beneath our feet. Way down below the crust, the planet has been cooling down for billions of years, just not evenly. The Pacific side loses heat faster, while the African side slows that loss by trapping it longer. That difference is why Earth stays restless, with earthquakes tearing the ground apart and volcanic fire breaking through the surface. Think of Earth like a massive engine that's been shut off. The outside cools first, but deep inside, heat lingers. That internal heat is leftover energy from when the planet formed, and it's been slowly trying to escape ever since. For a long time, scientists assumed Earth lost heat evenly in all directions. Hot in the middle, slowly cooling everywhere else. But when a team at the University of Oslo ran simulations that rewound the planet 400 million years and tracked where the heat actually escaped, they saw something very different. The cooling wasn't symmetrical at all. One side of the planet is doing it faster than the other. The difference is striking. The Pacific Hemisphere, the side dominated by the world's largest and deepest ocean, has cooled by about 50 degrees Kelvin, which is roughly 90 degrees Fahrenheit difference, compared to the Africa-Eurasia side. The reason is basically insulation. Africa and Eurasia are on a layered ancient continental crust. The Pacific side is the opposite. It's mostly ocean, resting on a much thinner crust where warmth escapes easily. Plus, the cold seawater on top pulls that heat out non-stop. Because the Pacific side is cooling so fast, the rock deep underground is getting heavy and sinking back toward the core. It's like a giant slow-motion conveyor belt that drags the Earth's crust down with it. Heavy materials sink. As it sinks, it pulls on the edges of tectonic plates, creating stress, trenches, earthquakes, and chains of volcanoes. Most of Earth's earthquakes and volcanoes happen in a giant loop called the Ring of Fire. This is where the ocean floor gets cold, heavy, and sinks deep into the planet. All that sinking rock travels thousands of miles down until it slams into a massive continent-sized structure sitting right near Earth's core. Scientists call this a blob because the heavy ocean floor is constantly falling on top of it. The Pacific blob is squashed flat and pinned down, sitting heavy and locked in place. But the other half of the world is doing the exact opposite. Under Africa, there aren't many sinking plates to act as a weight. Without that pressure holding it down, the African blob is free to grow tall and light. It pushes upward, lifting the ground from below and reshaping the entire continent. In fact, that rising bubble is already starting to tear the surface apart. In East Africa, a massive crack known as the Great Rift Valley is slowly opening up as the ground is pushed from below. Eventually, the pressure will become so high that Africa will literally split in two, allowing a brand new ocean to rush into the gap. There's a cool theory that suggests these blobs might actually be the remains of an ancient planet named Theia. Some researchers believe that Theia crashed into Earth billions of years ago, and while part of it broke off to form the moon, some heavy chunks might have sunk deep inside our planet. So, the reason our interior is so lopsided might be because we literally have pieces of a different world buried inside our own. But that's just a wild theory. Whatever their origin, the blobs matter because they help split the planet into two different behaviors. On the Pacific side, cold slabs keep sinking down and piling up. On the opposite side, heat builds up deep and pushes upward over time. One half is dominated by downward motion, the other by upward motion. And this imbalance doesn't stop at the mantle. It shows up at the very center of the planet because Earth's inner core is still growing. Liquid iron around it gradually turns solid and attaches to the core. This process doesn't progress at the same rate everywhere. One side of the inner core builds up faster than the other. This might sound like it should throw the planet off balance, but it doesn't. Earth's interior isn't rigid like a solid metal ball. Over time, stuff inside can gradually move around. Gravity pulls everything toward the center, helping everything get a bit smoother and keeping the core pretty round. But pretty round doesn't mean perfect. If you want a real example of how uneven Earth is on the inside, look at the Indian Ocean. Where there's more mass underground, gravity pulls a little harder. Where there's less mass, it pulls less. In the middle of the Indian Ocean, there's a huge anomaly called the Indian Ocean Gravity Hole. In that spot, Earth's pull is weaker than normal, so weak that it can't hold the ocean surface up at the usual level. The water actually dips downward. You wouldn't notice it sailing through, but you'd technically be sitting about 300 feet lower than the rest of the world's oceans. It's an invisible valley in the sea caused entirely by missing mass deep inside the planet. However, Earth isn't the only world hiding a messy interior behind a smooth surface. Even the moon is like this. Over billions of years, Earth's gravity slowed the moon's rotation until it locked into place, keeping one face permanently pointed toward Earth. That's what we know as the near side and the far side. This mattered early in the moon's history. The near side always faced Earth, while the far side always faced deep space. That long-term setup affected how heat was stored and released inside the moon. When NASA mapped the moon's gravity using two spacecraft called GRAIL, they measured something called the love number. It's a value that tells scientists how much a planet or moon flexes under gravity. The moon's love number turned out higher than expected, which meant its interior was softer than it should be. When scientists looked closer at the gravity data, they found that most of this flexibility came from the side facing Earth. The moon's near side is softer and warmer deep down, while the far side is cooler and more rigid. Measurements suggest the near side mantle is significantly hotter and more volcanic. That difference shows on the outside. Because the near side was so hot and soft, ancient lava could easily punch through the crust and flood the surface. That created those big dark patches we see at night. On the other hand, the far side stayed colder and stiffer, so the lava never flowed the same way. Back on Earth, the Pacific has another quirk worth mentioning. Our planet isn't just spinning in place. It orbits the sun at over 66,000 miles per hour, and the entire solar system is moving through the galaxy like a car driving through a swarm of bugs. Over long periods of time, objects drifting in from deep space are more likely to hit the side of Earth that's moving forward. And because the Pacific Ocean covers such a huge stretch of that side of the planet, it naturally ends up catching more impacts than smaller oceans or continents. This creates a strange coincidence. The same hemisphere that is leaking the most heat from within is also the world's biggest graveyard for things arriving from the outside. Because it is so vast and lonely, space agencies even use its most remote coordinates as a spacecraft cemetery at a spot called Point Nemo. We deliberately aim satellites and massive space stations like Mir to crash right there. So, the Pacific ends up taking the hits from two directions, by accident from the universe and on purpose from us. Earth is restless, continents drift, oceans open and close. In a few 100 million years, the map will look completely different. The Pacific is actually shrinking right now. Eventually, the Americas might crash into Asia, and a new ocean will have to take over the job of being the planet's main radiator and its front bumper. But for now, we should probably be thankful for that massive, chilly, unlucky ocean.
So, what do you like to listen to? Music? Podcasts? Maybe the sound of rain or the crackling of a campfire. But what about listening to the ocean? Not the familiar crash of waves on the shore, but sounds captured deep on the cold ocean floor. Sounds that send chills down your spine. Sounds of something big, dark, and possibly alive. And the most unsettling part is this. The true nature of some of these sounds remains a complete mystery to this day. In 1997, something strange echoed through the Pacific Ocean. Deep beneath the surface, far off the coast of South America, a sound appeared so powerful that it instantly unsettled scientists. It was ultra-low in frequency, massively loud, and unlike anything recorded before. The signal was later given a simple name: the bloop. At first glance, the bloop sounds harmless, almost playful, but what it represented was anything but. It was so intense that it could be detected by sensors nearly 3,000 miles away. Imagine standing in New York and hearing something happening in Los Angeles. Now imagine that noise travel through deep ocean water, terrifying marine life and oceanographers. Whatever produced it had to be enormous. The signal carried patterns that felt like its source was some living creature. Whales were the first suspects, but even the blue whale, the largest animal in the world, simply couldn't generate a sound that loud. The numbers didn't add up, and that's when speculation took over. If something could produce the bloop, it would have to be larger than anything swimming in today's oceans. People began imagining creatures of impossible size, ancient sea monsters, the kraken. Some even whispered about the megalodon, a prehistoric giant shark thought to have gone extinct millions of years ago, and featured in dozens of videos right here on the bright side. The mystery only grew deeper when scientists mapped the approximate location of the sound's origin. It came from a region close to Point Nemo, the most remote place on Earth. This spot in the Pacific Ocean lies more than 1,000 miles away from the nearest land in every direction. It's so isolated that it's often called the oceanic pole of inaccessibility. Point Nemo is a place few humans will ever see. Because of its remoteness, it has become a kind of graveyard for defunct satellites and space debris. When spacecraft are decommissioned, they are often guided to fall into these waters. It's quiet, empty, almost untouched, and yet something powerful had screamed from nearby. For fans of cosmic horror, this detail felt oddly familiar. In the fictional universe of writer H.P. Lovecraft, the ancient sunken city of R'lyeh lies beneath the ocean near this very region. According to the stories, R'lyeh is where the monstrous entity Cthulhu sleeps. It's a powerful, scary, intelligent creature lying dormant for thousands of years, ready to awaken and bring about the end of the world. Of course, Cthulhu is pure fiction. Lovecraft never claimed otherwise. But once the internet made the connection, the idea took on a life of its own. But science eventually caught up. The bloop recording is still easy to find online. You can listen to it yourself. But it sounds so innocuous that you'll probably be disappointed. And today, we know with certainty that it didn't come from a living creature. Researchers later confirmed that the sound was produced by ice, specifically by an ice quake. Now, ice quakes occur when enormous icebergs fracture, crack, and break away from glaciers. When this happens, they release tremendous amounts of energy, generating ultra-low frequency sounds that can travel across entire ocean basins. These sounds are similar to biological calls, especially when recorded from far away and distorted by water. In fact, scientists compared the bloop to other known icequake recordings and found striking similarities. The source wasn't a monster. It was Antarctica itself during shifting, breaking, and reshaping. For many people, this idea brought mixed emotions. On forums like Reddit, some openly admitted they preferred the idea of a giant unknown life form. Yup. Another strange sound was captured in the early 1980s, deep in the South Pacific, during a scientific expedition near New Zealand. Researchers were exploring the South Fiji Basin, where the ocean floor lies more than 2.5 miles beneath the surface. There were short, sharp, repeating noises echoing through the water. 4 distinct bursts, each one sounding uncannily like a duck's quack. So, researchers called it the bioduck. The sound was rhythmic and consistent. Eventually, the team concluded that the source had to be biological, but identifying exactly what made the sound proved impossible. After sharing the data with colleagues in Australia, did they realize something even stranger? Similar sounds had been recorded in other parts of New Zealand and Australian waters. Decades later, the mystery remains unsolved. Some scientists believe the quacks may not be random at all. They could be a form of communication. Perhaps the sounds may come from Antarctic minke whales, though no direct proof exists. Scientists also noticed that there were several sources of sounds, and when one source spoke, the others fell silent, as if they were listening. It may have been a conversation echoing through the deep, in a language we still don't understand. Imagine a terrifying alarm blaring inside a secret laboratory, announcing that a monster from another planet has broken free. It's an ugly sound, loud, piercing, and oppressive, the kind that makes your skin crawl. In August of 1991, scientists recorded something eerily similar. Not in a lab, but deep beneath the Pacific Ocean. Across vast areas of the ocean, a strange, repeating signal began to appear at different times. It consisted of narrow, rising tones that lasted several seconds each. Researchers named this sound upsweep. It's detected most often during the spring and fall, leading scientists to believe it may be connected to seasonal environmental changes or changes in the source itself. But what exactly was producing it? No one knows for sure. The only thing scientists can say with confidence is that upsweep appeared near areas of suspected volcanic activity. But if this sound is natural, why does it seem so precise? So consistent? It almost feels artificial, as if a secret underwater facility is periodically broadcasting a distress signal from the depths of the ocean. Since its discovery in 1991, the upsweep signal has gradually weakened, making it one of the strangest and most unexplained phenomena ever recorded beneath the ocean. Now, there's another mysterious sound known simply as slow down. True to its name, this signal steadily decreases in frequency over 7 minutes before fading into complete silence. It was recorded in May 1997 on a hydrophone array located in the eastern equatorial Pacific Ocean. At first, slow down doesn't seem especially loud. But here's the chilling part. It was picked up by 3 separate sensors placed nearly 3,100 miles apart. Imagine how deafening and terrifying it was near the source itself. So, what caused it? The most widely accepted theory suggests that a massive drifting iceberg slowly came to a stop and ran aground. The idea is surprisingly plausible. A colossal block of ice is scraping along the seafloor, grinding forward until it finally halts. The location supports this theory as well, since the sound originated near shallow waters and small islands. Because of this, many scientists classify slow down alongside the bloop as a cryogenic noise caused by ice. Still, it remains just a theory. Officially, the sound has never been identified. And there's yet another eerie recording from the ocean. This one sounds like a moan, but scientists named it whistle. Go figure. It was recorded in 1997 and gives the unsettling impression that something enormous is sitting on the ocean floor and whistling. Researchers believe that something could be an underwater volcano. When they compared the whistle signal to previously recorded volcanic sounds from the Eastern Pacific, they found them very similar to each other. Most likely, all these sounds are of a natural source, volcanic eruption or iceberg collision. But it's still pretty scary to hear something like this while driving. It would be especially unpleasant to be directly above an erupting underwater volcano. Well, yeah.
Off the coast of Croatia, archaeologists have recently uncovered something incredible. A perfectly built stone road, still intact, buried under layers and layers of mud. It's almost 7,000 years old. Who built it? Why? And where does it lead? This road might have been lost forever, if not for sheer luck. Back in 2021, archaeologists were looking at satellite images of the island of Korčula, a little Croatian island in the Adriatic Sea. Suddenly, they noticed some strange shapes, odd patterns, half seen beneath the waters. Curious, they dove into the waters to check it out. That's when they uncovered something incredible, a sunken Neolithic settlement, the village of Solin. But the ancient village was just the beginning. In 2023, while exploring the site further, archaeologists found something even more breathtaking. A perfectly built stone road, still intact, buried under layers of sea mud. It was thousands of years old. The road is only 13 feet wide. It's laid carefully, stone by stone, a ghost of a forgotten world stretching across the seabed. This was no accident of nature. The stones were too precisely shaped, too deliberately placed. And somehow, across 7,000 years of storms and tides, both the village and the road survived. One of the scientists said it's a miracle. The islands around Korčula shielded the coast from massive waves. This spared them both from destruction. They also found something else. Ceramic fragments and flint knives, small whispers of the people who lived here in the past. But who were they? The mysterious road goes way back into the Stone Age. An ancient culture called Hvar culture lived on the Hvar Island nearby. But they also spread across the eastern Adriatic coast and built the village of Solin just offshore from the coast of Korčula Island. The road connected the village to the main island. If you set foot on Hvar Island today, you'd see a fascinating island of pine forests, lavender fields, and sunlight that spills across vineyards. But you'd also be stepping into a living mosaic woven from 7,000 years of history. Neolithic people lived there around 4,900 BCE. That was before the rise of cities, before the pyramids of Egypt, before history even had their first kings. These people found shelter in the island's caves. In local places like Grabcheva Cave and Markova Cave, they crafted delicate, painted pottery, some of the oldest in Europe. This ancient settlement once bustled with life, perched near beaches where now only waves roll. The people who built it walked barefoot over its stones, carrying baskets of grain, tools, and clay pots filled with water or olive oil. Among those little shards, archaeologists discovered something amazing: the oldest depiction of a boat in all of Europe. Even in 3,500 BCE, the people of Hvar were dreaming of journeys beyond the horizon. And even though the Neolithic farmers of Hvar culture didn't have great technology, they had already learned to tame the earth. They built megalithic stone tombs, raised circles of rock in nearby Gradina Bay, and crafted intricate flint blades and stone axes. Why are Selene Village and the road underwater now? We don't know for sure. Perhaps something happened to them in the past that caused this. In any case, the road and Selene are all we have remained from those days. Havar Island was always a fascinating place to live in. The island's history is rough and beautiful, carved by rebellions, pirates, and foreign kings. Around 385 BCE, the Greeks sailed across the sea and found this beautiful island. A high limestone ridge, hidden freshwater springs, and fertile plains kissed by the sea breeze. No wonder they decided to settle here. These Greeks themselves came from Paros, a sunny island in the Aegean Sea. When they got to Havar Island, they found a town they called Pharos. They weren't being super original. Now we know this town as Stari Grad, which means Old Town, and it actually is one of the oldest towns in all of Europe. They brought with themselves deep knowledge of farming, sailing, and city building. This helped them to do something extraordinary. They divided the land into perfect geometric squares, neat fields for vineyards, olives, and grains. This perfect patchwork of farms is now called the Stari Grad Plain, and it's still so pure and unchanged after more than 2,000 years that it became a UNESCO World Heritage Site. Later came the Romans. Their villas and roads now also threaded across the hillsides. Then came the Croats. Their traditions, from religious processions to the haunting ancient songs of Holy Week, have survived the passing of centuries. But it was under the Venetians, which was about the 15th century, that Havar truly blossomed. When the Venetians came there, they chose Havar town as a major port. They built fortresses and arsenals, cathedrals, theaters, and squares. It was the golden age of Renaissance, and Havar brought three genius giants of Croatian culture to the world. The first one was Petar Hektorovic. He captured the life of fishermen and the spirit of the sea in his epic Fishing and Fisherman's Talk. In a local castle, the Tvrdalj Castle, his stone villa still guards its secret fish pond. The second one was Hannibal Lukic, who wrote The Slave Girl, the first secular drama in Croatian culture. And finally, Martin Benetovic, a painter, musician, and playwright who left his mark on the island's soul. In the Franciscan monastery by the sea, there's a beautiful painting stretching across an entire wall, The Last Supper. Not the original by Da Vinci. This one is thought to be created by Matteo Ingoli. Same theme, but a different artist, though this work is considered a Renaissance masterpiece. Back then, Havar Island became a jewel of the Venetian Empire, a naval stronghold, and later, a stage for Renaissance poets. But this place wasn't always peaceful. In the 16th century, the Ottoman Empire came here. Their corsair raiders swept across the sea and wanted to conquer the island. Havar's people built fortresses that still cling defiantly to the cliffs, even to this day. Napoleon also came here, but even all this couldn't drown Havar's spirit. Life always returned to the fields. Lavender bloomed purple over the terraces, rosemary and olive trees tangled the hillsides, and wine flowed from vineyards that the Greeks once planted. And still, the culture lived. In the 17th century, the island founded something unheard of: the first ever public theater in Europe. Before, theaters were meant for kings and nobles alone, but this one was a place where commoners and nobles sat together beneath carved stone arches, watching plays lit by candlelight. The locals also founded the first ever professional European Tourist Association. Tourism began early with the formation of the Hygienic Society of Havar in the 19th century. Today, Havar is known as the Island of Lavender and is crowned the Queen of the Dalmatian Islands. In the square of St. Stephen, the Cathedral of St. Stephen rises. Its bell tower, also built back in the Renaissance, once warned of Ottoman raiders. In the Benedictine nunnery, unseen by any but a few, the sisters weave agave lace. The threads are pulled from the agave fibers, knotted into impossibly delicate patterns, each one unique, each one a prayer captured in cloth. High above the town, you can still see the ancient cannons aimed out to sea, and below them, the glittering sweep of the Pakleni Islands, looking like little emeralds. There's more sunlight in a year than almost anywhere else in Europe, and the rich history in every festival, in the beauty of the Holy Week processions, and in the old songs that drift on the sea breeze. Roofs fly off like paper, huge trees are yanked from the ground, power lines snap and leave neighborhoods in the dark, streets flood like rivers, homes are left in ruins. That's a hurricane passing through. After the wind calms down, the real mess begins. People stranded, no clean water, destroyed roads. Storms have been picking up for like 5,700 years. And the scariest part is that in the last 20 years, there's been a huge spike. But let's start from the very beginning. This is Belize, a small country on the northeastern coast of Central America. And this is the Great Blue Hole, a huge, deep underwater sinkhole about 410 feet deep and approximately 50 miles off the coast of Belize. It formed around 10,000 years ago when the sea levels rose after the last ice age. A team of scientists arrived in Central America to study mud from way down in the Great Blue. They pulled out a long sample of sediment, which is basically layers of stuff that's settled over time. You might ask, so what? How are tropical storms connected with this sediment? Let's see. Tropical cyclones are big, spinning storms that form over warm ocean water. They pull up heat from the sea and blast it into the sky. And yeah, they can be devastatingly destructive, with super strong winds, heavy rain, and floods from big waves. And mud cores like the one the researchers pulled up are actually records of tropical storms. The sample they pulled up was 98 feet long, which made it the longest ever found in that area. Here's how it works. Every year, two thin layers of sediment settle in the hole where the weather is calm. But when a big storm hits, it leaves behind a different, messier layer. So by looking at these layers, scientists could tell how many storms hit that spot over the last 5,700 years. It's like counting tree rings, you know? Anyway, what they found was rather unexpected. It turns out that tropical cyclones had been getting more and more common. The lead researcher said that over the past 6,000 years, there were usually between 4 and 16 tropical storms or hurricanes every 100 years. But just in the last 20 years alone, they found signs of 9 storms in that same little area. That's way more than usual, and it shows how much things are changing. Scientists think there are 2 main reasons why tropical storms have been happening more often. One reason has to do with something called the Intertropical Convergence Zone, or ITCZ. This is an area near the equator where winds from the north and south come together. That spot has low air pressure, lots of moisture, and tons of thunderstorms. Just above it is the part of the Atlantic Ocean where most hurricanes are born. It even has an official name, the Hurricane Main Development Region. Normally, the ITCZ moves north in the summer and south in the winter because of changes in ocean temperatures. But over the past few thousand years, it's slowly been shifting farther and farther south. That's why the area where storms usually start has also moved south. It means storms are now forming and heading toward lower parts of the Atlantic than they used to. The second reason for the recent spike in storms is rising ocean temperatures. Earth has gotten warmer, and the ocean has warmed up too. The warm oceans help make more powerful storms. Such an increase likely means that this part of the world might see a lot more big storms in the future. If things keep going the way they are, scientists think the Caribbean could get hit by as many as 45 tropical storms and hurricanes by the end of this century. That's way more than anything the world has experienced in the last 5,700 years. There are just too many changes in the world that influence the situation. They create the perfect conditions for more storms to form and get really intense really fast. But if you think storms are getting more intense only over the ocean, let me tell you about America. a bunch of really dangerous storms, including tornadoes, dust storms, and wildfires, tore through several states in the Midwest and south of the USA in March 2025. At least 42 people lost their lives, and the scale of the devastation is enormous. What's scary is that most of this destruction didn't happen in the usual Tornado Alley area. Tornado Alley is a nickname for a part of the US where tornadoes happen a lot. It stretches through places like northern Texas, Oklahoma, Kansas, Missouri, parts of Louisiana, Iowa, Nebraska, and even eastern Colorado. But this time, storms hit places like Mississippi, Arkansas, and Alabama. Experts had warned this might happen. At the beginning of 2025, they said that tornadoes could start showing up more often farther east than usual, and that's exactly what's happening. One of their top weather experts said people in the Mississippi and Tennessee valleys should get ready for a rough spring. There are more people living in these areas than in traditional tornado zones, and many of them live in mobile homes or buildings without basements, which puts them at more risk when big storms hit. A tornado is basically a spinning tube of super strong wind that comes down from storm clouds and touches the ground. They can be really dangerous. To figure out how strong a tornado is, scientists use something called the Enhanced Fujita Scale. It goes from EF0, which stands for the weakest tornado, to EF5. Such a tornado is crazy strong, tear your house apart strong. The main question is, why are tornadoes happening more in the east now? In the US, tornado season usually kicks off in March. That's when cold air from Canada bumps into warm, wet air coming up from the Gulf of Mexico. And boom, storms start to form. But this year, things are a bit different. Here's what's going on. There's a big patch of high pressure, basically a chunk of calm, warm air hanging over the southwest. That's keeping things more stable out west, so fewer thunderstorms as well as fewer tornadoes are expected there. So, tornadoes are shifting eastward. Meanwhile, the Gulf of Mexico is super warm this year, and that's helping storms form in the southeastern US. The warm water adds a lot of energy to the atmosphere, which can lead to stronger, more frequent storms in places like Mississippi, Alabama, and Tennessee. Up north, around the Great Lakes and Northeast, it's staying cooler this spring. That means fewer big storms up there, at least for now. Now, let's get back to those devastating March storms. On March 14 and 15, a huge storm system blasted through parts of the central and southern US. This system brought 52 confirmed tornadoes, massive dust storms, and fast-moving wildfires. It all led to almost 1,100 canceled flights. About 150 million people were affected by this natural disaster. Two really strong tornadoes classified as EF4s hit Arkansas. The damage was incredible. One of those tornadoes, which hit a town called Diaz, had winds up to 190 miles per hour. That's insanely fast. For comparison, the average speed of a Formula One car is around 130 to 160 miles per hour. It was the first time in over 25 years that Arkansas got hit by two EF4s on the same day. Experts also recorded wind gusts moving at a speed of over 80 miles per hour in the southern plains. In Texas, dust storms led to fatal car crashes. Wildfires, caused and driven by the strong winds, burned through parts of Texas and Oklahoma. Oklahoma alone had more than 130 fires. So, what's next? Experts think the US could see between 1,300 and 1,450 tornadoes in 2025. That's way more than the usual 1,225. And it's not just about tornadoes. A warmer atmosphere can hold more moisture. That means heavier rains, more flash floods, and even more powerful storms. Basically, the formula is the following. Warmer oceans plus warmer air equals stormy weather, especially in the east and southeast. But even if you don't live in any of these areas, you can't feel completely at ease either. Experts say tornadoes and other natural disasters can happen pretty much anywhere in the US. The risk moves around depending on the time of year and the weather. In some regions of the Pacific Ocean, ships sink very easily, which is why it is feared by many sailors. Although there are many routes in that area, there are some that few dare to risk because crossing them can mean facing extremely dangerous forces of nature. If you need to travel from Asia to America by ship, the most obvious route would be the shortest and quickest. That is, a nearly straight line under the North Pacific Ocean. But instead, it might be better to avoid crossing this place and opt for longer and more expensive but much safer routes. There is not one, but several reasons. The Pacific is home to some of the most dangerous waters in the world. When we open a world map, we usually see that the Pacific Ocean is kinda divided, which prevents us from realizing how big it is. But in reality, this giant covers almost a third of Earth's surface. It's about 10 times larger than the smallest ocean in the world, the Arctic Ocean. In other words, when crossing it, the chances of being cut off from any landmass are very high. And in cases of emergencies, mechanical failures, or even storms, help might take days or even weeks to arrive. This significantly increases the risk of serious accidents, the possibility of cargo loss, and, in more serious cases, something even worse. Now think about it. A ship journey from Santos, Brazil to Cape Town, South Africa covers a little more than 3,400 miles. To get from Callao, Peru to Shanghai, China, you need to travel around 10,000 miles. Another major problem that prevents sailors from crossing the Pacific is storm systems, whose name already indicates what they contain: unpredictable and therefore dangerous storms. In addition, near the equator, there is a chain of winds called trade winds that directly influence the climate in the tropical region and occasionally cause rain. Trade winds are strong and constant winds that act like a whirlwind that rotates without stopping. And although they are extremely important for nature, as they spread moisture through forests and even influence the formation of deserts, they pose a problem. Their intensity changes depending on the season. In winter, for example, they can be much stronger. And since these winds are responsible for moving the ocean waters, they also create strong sea currents that could make the journey much more dangerous. In 2015, researchers came across a series of extremely strong winter trade winds that caused a surge of short but intense waves in the Pacific Ocean. They observed that those waves began to hit the ship with constant force, as if they were repeatedly punching it. As a result, the hull structure was completely twisted and deformed. And in the end, they confirmed what they had already known. Those waves, caused by winter trade winds, could be a real threat to vessels. And by the way, do you remember that help in the middle of the Pacific can take a considerable amount of time to arrive? So, now there is much more than one reason behind the hostility of the winds. Such a large ocean doesn't have many geographical barriers, such as mountains or large islands. It means that there are no land structures around it that could hold back or slow down the winds and currents. So the trade winds and ocean currents have complete freedom to gain strength and speed. This explains why the Pacific is the scene of powerful storms and giant waves. This is different, for example, from the North Atlantic, where North America, Europe, and Africa help to contain and redirect the atmospheric and maritime systems. It is now very common for scientists to see the bottom of the Pacific Ocean as a giant jigsaw puzzle because it's literally full of moving pieces. It's home to the largest number of tectonic plates on the planet, and one of them, the Pacific Plate, is the largest maritime plate that science has ever identified. This particularity makes the region extremely unstable to earthquakes and volcanic eruptions. Even though the ocean may seem calm at first glance due to its geology, things can change very quickly. This makes it unpredictable and treacherous. For example, in 2022, the cargo ship 1 Apis was crossing the ocean, 1,600 miles northwest of Hawaii, when it was caught in a torrential storm. As a result, more than 1,800 containers were damaged, falling to the bottom of the sea. Hundreds more collapsed on the deck, turning into a real-life steel domino due to the force of the wind. The captain managed to steer the ship to Japan. The journey lasted about a week, and it was only when they got there that they understood the extent of the loss. But it wasn't just the 1 Apis. The following year, the ship Maersk Essen lost about 750 containers, while the Maersk Eindhoven lost more than 260. In both cases, the routes were bound for Asia. These three alone have already accounted for much more than the global annual average of containers lost at sea, which is about 1,382 per year. And the most curious thing is that these events happened in winter. Speaking of winter, it was in the winter of 2020 that the Pacific made history. Scientists recorded a 58-foot-high wave in the ocean, which is equivalent to the height of a 5 or even 6-story building. In general, a wave is considered giant or extreme when it's more than twice the height of the others around it. This one, however, was almost 3 times bigger than the rest. Now, it's important to remember that despite being rare and scary, these waves are not a tsunami, as they're caused by wind. Tsunamis, on the other hand, usually occur after underwater earthquakes or volcanic eruptions. Another big monster of the Pacific are typhoons, and the 2024 typhoon season confirmed this. One of the highlights was Hurricane Christy. It did not touch the crust, meaning it did not cause direct damage, but we cannot underestimate it. Christy reached Category 5 on the Saffir-Simpson scale, which is the maximum level. A hurricane of this degree is considered catastrophic, so it's no wonder that it was powerful enough to generate huge waves and extremely dangerous rip currents. In addition to this, there was also Super Typhoon Yagi, which hit the Asian continent with such force that it gained the reputation of the most powerful in the last 70 years. When it arrived in Vietnam, it caused around $1.6 billion in damage, destroyed infrastructure in several cities, and left a trail of victims wherever it went. As if that weren't enough, the Pacific is also home to one of the most unstable regions on the planet, the famous Pacific Ring of Fire. It's a huge, crack-shaped area that's home to intense volcanic and seismic activity. It's the most tectonically active place in the world, as the plates of the Earth's crust are constantly moving there. They move apart and collide, or grind against each other, which causes the region to experience earthquakes and volcanic eruptions all the time. Seismographs record some type of tremor there every 5 minutes. This dangerous region is responsible for about 90% of the planet's earthquakes. So, 9 out of 10 tremors occur within this ring, which stretches across the northern Pacific. And the worst part is that it doesn't just affect North America or Asia. In 2023, tremors linked to the Ring of Fire were felt in several Latin American countries, such as Argentina, Chile, Ecuador, and Peru. There was a trail of destruction, and the lives of around 15 people were lost. There's no shortage of reasons for ships to avoid the shortest route across the Pacific and opt for longer routes. As the popular saying goes, prevention is better than cure. Around 5.3 million years ago, a crucial event reshaped the Mediterranean region. It was a colossal flood that refilled the local sea, which had been extremely barren and salty up until that point. It got the name Zanclean Flood, and it forever changed the geography of the area. The Mediterranean Sea is surrounded by Europe, Africa, and Asia, and connects to the ocean by the Strait of Gibraltar. This is quite a narrow passage, measuring about 8 miles. It may not be that wide, but the strait plays a crucial role in maintaining the liquid balance between these two bodies of water. About 6 million years ago, a bunch of things might have caused the Mediterranean to be cut off from the Atlantic Ocean. Some say it was an ice age. Others speak of tectonic movements, like earthquakes. Whatever the cause, it pushed the Mediterranean area into a period called the Mycenaean salinity crisis. For about 1,000 years, the sea slowly evaporated, leaving behind a dry basin that was several miles below sea level. This crisis really changed the landscape, creating conditions similar to those found in today's Dead Sea. What this means is that the lush Mediterranean beauty used to be a super salty environment, containing nearly 10 times more salt than the ocean. Say you could have visited. You would have been able to effortlessly float on the little water you could find, even if you're not a skilled swimmer. The amount of salt and that mineral content would have made it challenging for most creatures to survive. However, some hardy microorganisms, such as bacteria, could have adapted to these harsh conditions. These days, at the bottom of the Mediterranean Sea, we can find holes as large as the Grand Canyon, and they seem to have formed during that same period of dehydration. Evidence suggests that massive rivers, such as the Nile and the Rhone, flowed directly into the Mediterranean back then, leaving behind canyons as they reached the bottom, thousands of feet below the sea level. People had to find some sort of explanation back in the day for the drying of the Mediterranean, so they came up with myths and legends. One such tale was told by the people of southern Iberia, in modern-day Spain and Portugal. It was also recounted by a famous Roman writer called Pliny the Elder. What this legend said was that the Mediterranean used to be cut out from the ocean until the hero Hercules, with his mighty sword, carved a path. He did so between a fictional location in modern-day Africa and the Rock of Gibraltar. This allowed the ocean waters to flow in, transforming the Mediterranean into what we know today. Some fossils also seem to confirm the unusually large flood. Remains of marine organisms were found in layers high above current sea levels. This means the areas were once submerged underwater. These fossils belong to mollusks, fish, and marine mammals. Because of modern techniques, we now have at least an estimated timing of the Zanclean flood. Scientists used computer simulations to reconstruct the event, providing further evidence that it was real. What they also discovered is that there's a possibility the Mediterranean might change once more. The Strait of Gibraltar could close, most likely because of movements deep under the ground. This could lead to the Mediterranean becoming dry again, over a span of about 1,000 years. The Mediterranean area could disappear altogether if the African continent keeps shifting north too, getting closer to Europe. Another one of those famous yet still a bit hypothetical large floods is called the Black Sea Deluge theory. Some scientists think that around 8,400 years ago, water from the Mediterranean might have spilled over into the Black Sea through a narrow passage called the Bosporus Strait. This could have caused a massive disaster, forcing people living near the Black Sea to pack up their things and move further inside the continent in both Europe and Asia. Along with them, they might have carried stories about this colossal flood. The specialist that came up with this idea also suggested that these migrating people might have brought along new ways of farming. Not everyone from the scientific community is convinced, though. Some argue that while there might have been a flood, it likely happened earlier and was way smaller. They didn't think this flood could have caused, for example, the story of Noah's Ark. In this legend, a spiritual man was warned by a higher entity that a giant flood was on its way. The man went to gather pairs of animals and pack them all in a boat to make sure these species would survive the devastating flood. There was also the concern among scholars that discussing real floods and ancient stories too much might blur the lines between science and fiction. There may be other reasons why these flood stories are so often found across different cultures all over our planet. One idea is that floods were incredibly destructive for early farmers, so they invented myths about them signaling the end of the world. Another idea is that people stumbled upon ancient sea creature fossils in unusual places, leading them to believe there was a significant flood in the past. The solution to future floods, though, might be floating cities. As sea levels continue to rise, coastal cities like Amsterdam, New Orleans, and Venice may go under. So, floating infrastructure may be the way to go, with buildings that can rise with the water levels, making them able to resist extreme weather too.
Countries like the Netherlands, which have a history of managing water risks, are pioneering these floating creations. With cities running out of space for expansion, we might be forced to move on water anyway. By moving on the water, we can reduce crowding and create more interesting ways to feed ourselves, like floating gardens. These homes also come with great alternatives to our energy needs through systems that use solar and wind power. Not to mention that these homes might turn out to be cheaper in the long run. One such floating city might pop up soon in the Maldives. Its goal is to host up to 20,000 people and will feature places to live and eat, but also shops and schools. Designed to look like coral, the region will include canals placed between some 5,000 floating pieces of land. The city will be constructed using modular units, put together in a construction site nearby. After they're completed, they'll be towed to the floating city. The next step is to secure them to a large underwater concrete hull, which is screwed tightly to the seabed on some steel stilts. All these pieces of construction let the modular units easily move as naturally as the sea. Even for those that are afraid of seasickness, there's a solution. That's what the nearby coral reef is for. It will surround the city, making a natural wave breaker. Human-made coral banks will also be placed underneath the city, which will also help coral grow naturally. The long-term goal is to make the establishment self-sufficient. It will have electricity, mostly from on-site solar power. Waste will be treated nearby and reused as plant fertilizer. Instead of air conditioning, the city will use deep-sea water cooling. This method pumps cold water from the deep sea to cool the area, saving energy. Earth is not the only planet that's seen some serious floods. In ancient times, Mars seems to have experienced them too, and they played an important role in shaping its surface. Recent research reveals that billions of years ago, Mars was heavily affected by some serious river flooding, which contributed to the formation of its valleys and canyons. The reason for these floods was heavy rainfall, which reshaped the Martian landscape in a jiffy, at times even within days or weeks. Unlike Earth, where rivers form pretty slowly, Mars experienced rapid changes because of these floods, particularly around 4 billion years ago. We've known for quite some time that there have been floods on Mars, but this study really showed us their extent. We now know they were more widespread and frequent than previously thought. You find yourself at a food fair in Iceland when you see it for the first time. Volcano bread. You eat a slice and oddly enough, it actually tastes good. Unsure of how this works, you check out the baking process. Is this kitchen really strange looking, or is it just me? The baking spot is in nature, specifically in a hot springs field. You better watch your steps so you don't get burned by the hot vapor jolting from the ground. Now, a local baker shares their traditional rye bread recipe with you. Rye flour, check. Yeast, check. You mix it all together and pour it into a metal pot. Next on the list is digging the hole where you'll place the pot to bake. You dig for about 16 inches until you can see the water bubbling from the ground. If you want to do it like a local, you'll use your finger to check the water temperature. Yikes, that's hot. Actually, the ground is heated by lava. Iceland is one of the most volcanic regions in the world, with over 30 active volcanoes at any one time. After you bury the bread in volcanic soil, you leave it there and wait 24 hours until it's ready. The next day, the bread is fully baked and super tasty. And the best part is, you just participated in an ancient Icelandic tradition. People have been doing this since at least the 1800s. Imagine it's your first day of work in a museum, and your assigned task is to clean the mask of Tutankhamun. You grab your cleaning utensils and then, oh no, this can't be happening. You just broke Tutankhamun's beard. I never wish this to happen to anyone, but this is actually a true story. Back in 2014, an employee at the Egyptian Museum knocked off the beard of Tutankhamun's mask and glued it back on, hoping no one would notice. This mask was discovered in 1922 and is considered one of the 10 symbols of our human civilization. Oh, and the best part of this story? It took historians until 2016 to discover the poor glue job. So, if you visited the museum between 2004 and 2016, Maybe you saw the glued beard. If I say Sahara, what comes to mind? An infinite desert landscape, right? Well, according to scientists, the Sahara isn't always a desert. From time to time, it becomes green. But you probably won't be seeing this in your lifetime. Every 10,000 years, the Sahara lives through a humid period, where the sand gives way to lush green vegetation and sparkling lakes. This happens due to a tilt in the Earth's axis, which affects different weather patterns around the globe. Can you imagine the Sphinx surrounded by rainforest? It's mind-blowing. And speaking of the Sahara, say you traveled back to 1800 BCE. If you timed it right, you might get to see the construction of the so-called Black Pyramid in the city of Dashur. These are not the famous Giza pyramids, but they serve the similar purpose of being a final resting place. In 1892, archaeologists excavating the area found an important part of the Black Pyramid that was lost for centuries. The benben, also called a pyramidion, was the tip of ancient Egyptian pyramids. A benben consists of a solid block, usually made of limestone. Most of them were covered with gold and reflected the first rays of light from the sun every day. Can anyone get me a time machine, please? Remember when you ate something really spicy, your cheeks turned red? Apparently, that can happen to birds too. For example, canaries can change colors after eating peppers. These birds have a special pigment that allows them to switch shades depending on their diet. So, if a yellow canary eats red peppers, it can turn orange or red. Can rocks move on the ground on their own? Well, you might be under that impression if you visit Racetrack Playa in California. The site is a dry lake bed and home to one of the world's strangest phenomena, the so-called sailing stones. Think 100-pound rocks moving around alone, leaving behind trails as long as 1,500 feet. They were discovered in the 1900s, and until recently, no one was lucky enough to be on the site while they were moving. It was only in 2014, after much observation and research, that scientists solved this mystery. The sailing stones appeared because of the perfect balance between wind, ice, and water. When it rains, the water that falls on the ground freezes and forms a coat of ice above the ground. If it's windy, the rocks are easily pushed around, sailing along the lake bed. But hey, if you ever visit Racetrack Playa, don't disturb the rocks. On the western coast of France, you'll find the vacation hotspot known as the island of Ré. It attracts tourists looking for scenic landscapes and beautiful beaches, but that's not all it's famous for. There, an extraordinary phenomenon occurs when two different wave patterns collide with each other, something called a cross sea. It's almost as if the sea were a checkerboard, divided into hundreds of squares. And no, it's not an optical illusion. A cross sea only happens in places where different quality waters meet. For a tourist to see the cross sea in Ré, this probably means that there was a storm in a different sea nearby. This stormy water travels with the help of currents and meets the water of Ré, creating these oddly shaped riptides. Oh, and apart from this island and Israel, there's nowhere else in the world where you could see such a thing. The following sight will either give you goosebumps or make you marvel at its weirdness. I'd say it depends on the time of day you visit. Next to the small town of Gryfina in Poland, you'll find a very unusual sight, a pine tree forest where each tree is bent at its base. If you visit during the daytime, I guess you'll be fascinated by these trees' sharp 90-degree curves. You can even use their trunks as a stool if you decide to have a picnic, for example. But visiting the site at night will most likely give you chills. A thin layer of fog hovers around, making the forest seem quite unwelcoming. Scientists still can't explain why the trees are the way they are. So, are you a daytime or nighttime visitor? You went for a hike and suddenly encountered a big cloud of fog. This may ruin your photo ops, but there's one thing you can hope for. Foggy days are the perfect conditions for a phenomenon called fog bow, otherwise known as a white rainbow. This happens because of numerous tiny water droplets that cause fog, smaller than 0.002 inches. So, instead of the multicolored bow, you get a transparent one, with red outer edges and a bluish inner edge. Now, say you're roaming in a little town in Europe, appreciating the century-old buildings and good summer weather. You feel hungry and decide to type into your Google Maps the name of that restaurant your friend recommended. It's only 10 minutes away by foot. You follow the blue dot on your GPS and arrive at your destination, quick and easy. We all love this free piece of technology, don't we? But what if I told you that the US spends over $2 million daily to maintain the satellites to make it work? Yep, that's the price. And to implement it, they spent over $12 billion US dollars. Have you ever heard of something called a natural snowball? This could be proof that nature is really perfect. In 2016, the beaches of the Gulf of Ob in northwest Siberia were filled with rows of giant snowballs. Think balls measuring up to 3 feet across. This rare yet beautiful natural phenomenon happens when small pieces of ice are rolled by strong winds and water. The further they roll, the more ice they gather, and the more that ice is polished. They end up as giant, perfectly shaped snowballs. They look pretty amazing on their own, but it's quite a sight when hundreds of them are together.
So, look at this map. This is not the Google Maps you open on your way to work. Here, you can see the world's most mysterious places. From the Bermuda Triangle to the Pyramids of Giza. From the Islands of Dolls to Easter Island. So, grab your pith helmet and let's go. You're venturing deep into the Sahara. What's that on the horizon? It looks like the remains of a once thriving civilization. Near the city of Tiaret, 150 miles southwest of Algeria's capital, you can find 13 monuments shrouded in mystery. You see underground vaults and other constructions made of stone. They were built between the 4th and 7th centuries CE. Some chambers are interconnected with a labyrinth. Walking through it takes about 2 hours. People who once inhabited this place carved hunting scenes and animal figures on the walls. Researchers believe the place was built as a final resting place for the Berber royalty, but there's no way to prove it, and the abandoned city in the desert remains a mystery. Now, how about the Island of the Dolls? If this name doesn't give you the heebie-jeebies, I don't know what will. While moving down an ancient Aztec canal, you find this mysterious island. Hundreds of abandoned dolls are hanging from trees. There are so many, you lose count. Legends say it was a man who hung them there. He decided that one wasn't enough, so he spent his life hanging dolls on trees. Yeah, that's creepy. Speaking of creepy, in Mexican desert land, there's a spot called the Mapimi Silent Zone. People say no radio or any other kind of signal can be received there. I definitely wouldn't want to get lost there. In the far north of Canada lies inhospitable Lake Anjikuni. It's covered with snow and ice for half of the year. It was once home to the Inuit people. But something terrifying happened to this entire village. What exactly? This mystery is still unsolved. In 1930, Joe LaBelle was passing through a village that seemed deserted. He noticed that something was off there. There was no noise or any sign of human activity. He opened doors, one after another, but nobody was home. The inhabitants of the entire village were gone. They left behind 7 sled dogs. Those were still tied to their posts. No one has been able to explain this disappearance so far. One of the world's biggest mysteries is the Pyramids of Giza. The Great Pyramid of Giza itself was built as a final resting place for Pharaoh Khufu around 4,500 years ago. It remains unexplained how the Egyptians managed to build the pyramids without any of the technology available to us nowadays. Interestingly, the pyramids align with Orion's belt and all face toward the north. Yellowstone National Park is known for its beauty, but also for some bizarre accidents. For example, in the summer of 1929, hundreds of people visiting the site fell sick. It all began with 6 employees, but quickly spread to the staff and guests of different hotels. Until today, it's unknown what happened. People didn't eat the same food, nor did they drink from the same water source or stay at the same hotel. So, make sure to keep an eye out for anything strange if you're ever in the area. The River Nid in North Yorkshire is said to turn things into stone. People from all over the world come to see this phenomenon with their own eyes. Tourists and locals travel there to leave different items in the well. A bicycle abandoned in the well turned into stone several days later. An old teddy bear became a piece of rock. Many believe that whoever stepped into this water would have a similar fate. But according to scientists, this is just a natural phenomenon. Local water is rich in minerals that form a coating around objects. It's this hard shell that makes them look as if they're made of stone. Now, how can rocks slide across the ground on their own? At Racetrack Playa, a dry lake bed at Death Valley National Park in California, they do. These moving rocks, called sailing stones, have been observed since the early 1900s. Locals believe that strong winds push them around. Other theories involve magnetic fields. In 2014, researchers discovered that the rocks were actually pushed by melting panels of floating ice driven by winds. Way to go, science! The Bermuda Triangle is a world-known, notorious place. That's where over 50 ships and 20 airplanes have allegedly disappeared. Rescue missions never came back. It's located off the coast of Florida in the middle of the Atlantic Ocean. Unexplained disappearances there date back to the mid-19th century. There are different theories about why ships and planes vanish into thin air in this region. Some of them claim that the area is just extremely foggy, which makes it difficult for navigation. Another theory states that methane rising to the surface of the ocean can be the answer to this mystery, but no theory has been proven yet. In the mountainous country of Pakistan, you'll find the lost city of Mohenjo-Daro. This ancient archaeological site dates back to 2500 BCE. Scientists believe the city was built by the Indus Valley civilization. Here we see a well-planned street grid. And look at this elaborate drainage system. Nobody knows what happened to the people living in this town. The only thing scientists are almost sure about, it looks like something ended their lives all at once. Has the mystery of Easter Island finally been solved? You've probably heard of the fascinating monolithic statues standing on this Polynesian island. The statues, called moai, weigh up to 90 tons. They were built by the Rapa Nui people. How they managed to transport the statues remains unexplained. Researchers from the University of California believe the statues were built to make the soil on the island more fertile. And the coolest thing? The analysis has shown that the areas where the moai sculptures stand are indeed more fertile. The crooked forest in Poland is weird, to say the least. A grove of oddly shaped pine trees looks like something straight out of a sci-fi movie. The grove is home to around 400 pines that were planted in 1930. They all first bend toward the north and then continue growing upright. No one knows for sure why this happened. The surrounding forest is full of perfectly straight pine trees. Is there a monstrous creature living at the bottom of Loch Ness in Scotland? Whether it's a myth or reality, it sure is spooky. The legend of the Loch Ness Monster appeared somewhere around 1933. Since then, people have been claiming to have seen dragons, prehistoric monsters, and sea serpents in the lake. Will we ever know the truth? The Wharton Basin off the western coast of Australia is home to odd geological phenomena. Huge earthquakes happen there, one after another. This would be unsurprising if the area was located above a fault line, which is where two tectonic plates meet. But that isn't the case. The area is located on the Australian plate, but researchers believe that a new fault line might be forming there. This is the only reasonable explanation for what's happening in that area. One of the most isolated places on Earth, the North Pole, is as mysterious as it gets. A land of ice and odd disappearances. In the late 1840s, an expedition of more than 130 people, known as the Franklin Expedition, vanished in that region. Some evidence was found 150 years later, a leather shoe and snippets of journal entries. My own theory? They were all hired by Santa Claus to work in his toy factory. Yeah, no one else bought it either. Machu Picchu is also known as the Lost City of the Incas. It's a testament to the power of the Inca civilization. But the purpose of the site is still a mystery to be unraveled. The citadel was constructed at 7,000 feet above sea level around 1450 CE. The question remains, why did the Incas build a city like this in a place so inaccessible? Archaeologists have discovered that most of the city is built underground, and about 60% of the place remains unexplored. So who knows what might be hiding down there? The Mariana Trench is the world's deepest, darkest place. Imagine this: no sunlight, freezing waters. There seems to be little to no chance of life existing so deep under the surface. Yet, sea explorers claim to hear a bizarre sound coming from the depths of the trench. The records of this mysterious noise lead some to believe that a deep-sea monster is calling the trench its home. Alright, too spooky. I'm out of here. Before an earthquake shakes the ground, something sneaky might happen first. A slow, quiet movement with no shaking at all. No one is aware that right under their feet, the land is preparing to tremble violently, wreaking havoc, bringing destruction and devastation. A new study shows that such a slow creep might be how earthquakes begin. To figure this out, scientists didn't start with giant pieces of the earth. Instead, they went into a lab and used clear plastic sheets called plexiglass. They pushed two sheets of plexiglass sideways against each other, just like how tectonic plates, huge chunks of Earth's crust, push against each other underground. As they pushed, the plastic cracked, kind of like what the Earth does during an earthquake. And even though it was plastic and not rock, the physics, the way things break and move, was the same. Earthquakes happen when two tectonic plates try to slide past each other, but they get stuck. The edges between them don't move easily because of something called friction. It's kind of like when your shoes grip the ground. Over time, the plates keep trying to move and stress builds up. Think of it like bending a stick. At first, it doesn't break, but if you keep pushing, it will eventually snap. The spot where the plates are stuck is called a fault, and there's a thin, brittle part in that fault. By brittle, I mean that it doesn't bend, it just breaks. Here's how it happens. First, a tiny crack forms. It's small and moves slowly. There's no shaking yet, but something is already happening under the surface. The crack spreads, building up more energy. When it finally reaches the edge of the brittle zone, boom! It speeds up, suddenly racing forward really fast, almost as fast as sound. And that's when the Earth starts to shake. So scientists decided to find out how that very first crack starts. They conducted their experiment, whose setup was similar to a type of fault in the real world called a strike-slip fault, like the San Andreas Fault in California. Even though the materials, plastic versus rock, are different, the way cracks form and move is exactly the same. The experiment has helped scientists understand that earthquakes don't always start suddenly. Sometimes there's a slow, quiet start, like a warning sign before the big quake. This early stage of an earthquake is called a nucleation front. It's like a seed of a crack, gently creeping through the material long before any actual rupture happens. This quiet and slow movement doesn't release energy into the surroundings. At first, scientists thought of cracks as simple one-dimensional lines, like a straight tear in paper. But something didn't add up. The slow-moving nucleation front wasn't behaving like a normal, fast-moving crack, and it wasn't clear why or how it suddenly sped up and became an earthquake. The answer came when scientists realized they had to think in two dimensions instead of one. Instead of imagining the crack as just a fine line, they began to think of it as a patch, like a growing circle, that starts at the surface where two materials touch. As this patch spreads out, more material along its edge has to break. The important thing here is that the energy needed to break the material is related to how long the patch's edge or perimeter becomes. The bigger the perimeter, the more energy it takes to keep breaking. That's why this patch moves slowly at first. It doesn't yet cause the violent shaking we associate with an earthquake. Because it moves without sending shaking waves, this stage is called aseismic. Eventually, the growing cracked patch spreads beyond the special brittle zone, where the materials are stuck. Outside this zone, the energy needed to keep breaking the material doesn't increase anymore. Instead, there's now extra energy building up, more than what's needed to keep the crack growing slowly. This extra energy doesn't stay quiet. It suddenly powers the crack to move much faster, turning it into a full-speed rupture. That's the moment when the earthquake begins, and the ground starts to shake. These findings help explain how earthquakes might start off slow and silent before quickly turning dangerous. They show that small, slow cracks can suddenly transform into powerful, fast-moving ruptures if the conditions are right. Scientists believe that they can learn to detect the aseismic stage before a crack speeds up. It might one day be possible to predict earthquakes, or at least understand the warning signs better. Now, even though earthquakes are only the third most common type of natural disaster, they cause the highest number of fatalities. NASA plays an important role in studying earthquakes by using satellites that orbit the Earth. These satellites collect data and images that show how the ground changes after an earthquake. For example, they can detect when the land shifts, rises, sinks, or cracks. These surface changes help scientists learn more about the strength and impact of earthquakes. NASA's satellites can also track changes in nighttime lights. If a city goes dark after a quake, that's a clear sign that the area may have lost power and could need help. Now, how about we talk about the most common earthquake myths, like the one about megaquakes? Some people really worry about super huge earthquakes, but there's a limit to how big they can get. The size of an earthquake depends on the size of the fault where it happens. A longer and deeper fault can cause a bigger earthquake. For example, the San Andreas Fault in California is long, about 800 miles, but not very deep, around 10 to 12 miles. This makes earthquakes bigger than magnitude 8.3 on that fault very unlikely. The biggest earthquake ever recorded happened in Chile in 1960. It had a magnitude of 9.5 and occurred on a huge fault that was almost 1,000 miles long and 150 miles wide. Technically, there's no set limit on the magnitude scale, but an earthquake bigger than magnitude 12 would need a fault larger than Earth, which just isn't possible. Now, earthquakes can happen near the surface or deep underground. Most occur in Earth's crust or upper mantle, down to about 500 miles deep. But the deepest ones happen only at subduction zones, places where one part of Earth's crust slides under another. In California, almost all earthquakes happen in the top 15 miles of the crust. One exception is the Cascadia subduction zone in Northern California, which continues up through Oregon, Washington, and Canada. Another misconception is that the ground can open during an earthquake, but usually that only happens in movies. A giant crack opening and swallowing things up during an earthquake is just fiction. In real life, the ground on either side of a fault slides past each other. It doesn't pull apart or open wide. Small cracks or holes can happen during landslides or ground failures, but not along the actual fault line itself. Faults don't open up because if they did, there'd be no friction, and without friction, there wouldn't be an earthquake at all. Now, some people think California could break off and sink into the ocean during an earthquake, but that's not how it happens. The ocean floor is just lower land with water above it. California can't fall in. What's really happening is that southwestern California is slowly sliding north toward Alaska along the San Andreas Fault. The Pacific Plate, which California sits on, is moving about 2 inches per year, about as fast as your fingernails grow. So, in about 15 million years, Los Angeles and San Francisco could be neighbors, and in 70 million years, Los Angeles might be sitting near Alaska. I can't wait. People often wonder whether an aftershock can be bigger than the earthquake itself. Aftershocks are smaller earthquakes that happen in the same area after a larger one. They're like our planet's way of settling down after the main shock. But if an aftershock turns out to be bigger than the first earthquake, then we call the bigger one the main shock, and the earlier one becomes a foreshock. About 5 to 10% of earthquakes in California are followed by a stronger one within a week. It's also possible for 2 quakes in the same area to be about the same size. However, very large earthquakes are rare, so it's even rarer to see 2 huge ones happen close together.
This is Australia. And here, A little to the south is its island part called Tasmania. It's a giant island with beautiful and rich nature, great weather, and delicious food. But for some reason, very few people live here. Something makes people leave this place. Something prevents people from moving here. And this something is… let's find out. So, the population of Tasmania is over 500,000 people. That's not a lot. In fact, Tasmania is Australia's smallest state by population, but it's the 26th largest island in the world. Its area is about the size of Ireland or Switzerland. In other states, the area is much smaller, and there are quite a lot of people. For example, over 8 million residents live in New South Wales, more than 7 million in Victoria, and over 5 million in Queensland. Also, mainland Australia is much more likely to endure fires and scorching sun. Tasmania has a fairly cool climate and amazing nature. So, what's the reason? Why do so few people live here? Let's visit the southeastern part of Tasmania, where the Tasman Peninsula is located. If you look at the map, you'll see that there's the Tasman Sea connected to the boundless Pacific Ocean. So it looks like the Port Arthur we're going to visit is on the edge of the world. In the past, there was Tasmania's official prison here that opened in 1830. Prisoners served their sentences and worked at a logging station. It was hard work, and many could not survive it. It's scary to imagine what happened inside the walls of this prison and how many people stayed there forever. But think for yourself. The Tasman Peninsula is on the edge of the world. There's almost nothing here except wild nature. Prisoners arrived there on ships and spent long hours doing hard work. There was no air conditioning or a soft bed. There was no hope of getting out of there. Some guards treated them cruelly. They were starving. Some got bitten by venomous snakes. There was nowhere to escape. The prison closed in 1877, but even today, it still inspires horror among tourists. Not only because of its appearance and history, but also because of the strange phenomena that occur there. According to rumors and legends, the spirits of prisoners roam the territory of Port Arthur. And on Monday morning, you can hear bells ring in an old ruined church building. But the thing is, the bells haven't been there for a long time. Of course, those are all rumors, and there are no confirmed facts. But you might feel uncomfortable in this place because of its sinister past and creepy atmosphere. Port Arthur is one of the most mysterious places in Tasmania, but there's something worse. Welcome to Franklin House. It's a large estate with gardens and a huge building. There's a chance that as soon as you cross the threshold of this house, you will want to leave immediately. There are a lot of antiques here, but there's also something elusive and sinister in the air. This house was built by a former convict. 4 years after the construction, he leased the mansion to a schoolteacher who turned it into an academy for boys. It's not known what happened in the walls of this building in the past, but today, according to rumors, mysterious phenomena take place here. Objects move by themselves. Eerie noises come from empty rooms, and shadows of human figures are spotted in halls. Plus, according to a non-profit company that researches mysterious phenomena, there's an increased level of electromagnetic activity in this house. What does it mean? Nature? Weather? Or phantoms? Choose for yourself what to believe in. Okay, there are 2 creepy places in Tasmania, but the reason why people leave this place is different. We're getting closer and closer to it. Hobart is the capital of Tasmania, and there's an old prison here, where people still run tours. Tourists come here to tickle their nerves, because the most terrible sentences were carried out here. There are rumors about strange smells, flickering shadows, and a creepy atmosphere that make this place scary. Yes, if you're a tourist and come here for fun, you will get an interesting experience. But if you're a local and live nearby, then maybe it might bother you. But of course, an abandoned old prison wouldn't discourage people from living on a giant, picturesque island. There's a bigger reason. There's a city in Tasmania called Richmond. According to local legends, once upon a time, George Grover lived here. He was a security guard who kept order during the construction of the Richmond Bridge, which was built by convicts. George Grover was an evil man who treated prisoners cruelly. One day, the prisoners decided to take revenge on him and pushed him off the bridge. Since then, rumors have been circulating that the spirit of George Grover is walking under the bridge with his big black and white dog, which is called Grover's dog. Tourists and locals reported they had seen this evil security guard at night. He didn't harm them, but gave a severe fright. Many terrible events related to escaped prisoners also took place on the island, so judging by the history of Tasmania, there's been a lot of pain and misery here. Perhaps this affects the overall energy of the island. But is this the reason why so few people come to live here? Now we'll finally learn the most terrifying explanation. Are you ready? Please get away from the screens if you're faint of heart. There's almost no internet connection in some parts of the island. Boo! The signal is very weak and unreliable, which makes it impossible for people to work remotely and watch our videos. Besides, Tasmania is separated from Australia by the Bass Strait, which creates logistical difficulties for trade and traveling. Today in 2025, would you agree to live on a huge island with bad internet? You will also have to pay more and wait longer for the delivery of any goods. One of the main sources of income is tourism. In addition, rental prices are rising here, especially in central cities. Because of logistical difficulties, prices for food and necessities are rising here. One of the biggest problems is waiting lists in public hospitals in Tasmania. People who need modern medical care have to wait a long time for their turn, or they gotta spend tons of money to get to the mainland. Tasmania is getting old. More and more young people are leaving this place. There are no major corporate headquarters on the island. There are no large enterprises here like in Sydney and Melbourne, which means there are few career opportunities. Low salaries and unemployment are forcing young people to move to the mainland. The falling standard of living creates serious demographic problems. On the one hand, this is bad. The fewer people there are, the more difficult it is to raise the economy, to run agriculture, and somehow improve this region. But on the other hand, it's good for nature. About 24% of Tasmania's land area is a World Heritage Site. This territory is one of the last in the world to have cool rainforests. It's also home to one of the richest archaeological sites in Australia. Scientists found evidence that people lived here at least 20,000 years ago. Of course, these factors are not as creepy as the stories about haunted houses, but they can scare you away from moving to Tasmania. The idea that you live almost on the edge of the world, surrounded by the endless waters of the ocean, can be scary. You can meet unique animals that don't live anywhere else in the world and see incredible trees. For example, the Centurion tree, which is eucalyptus, is one of the tallest and oldest trees in the world. Its height is about 330 feet, and its age is about 400 years. The nature of Tasmania is incredibly beautiful. There's so much peace and calm here. In a sense, it's a paradise. But let's be honest, would you agree to live here considering all the nuances? Let's hope that people will find ways to improve the economy and raise the standard of living so young people won't leave this region.